Oh, it's coming up. Actually, my audio is off.
Nobody actually can listen.
I think somebody joined already.
Yeah. Hey, good morning, everyone. We are setting up here. Just give you a few minutes. We'll start. And if anybody wants to see the recording later, they can see it on the YouTube, and you can also download from there. We are recording already. Hello, mic test. That's the reason.
Okay, can you hear me now? I unmuted my Zoom.
That's interesting. We didn't see this yesterday. Okay. We'll begin.
Yeah.
Okay. All right. You guys can see me in Zoom. Can somebody respond? It's good.
Yes.
Okay. Perfect. Thank you. Okay. I think they cannot actually, if they can respond, if I have it on, you'll start hearing the, echo. That's fine. We'll begin. It's already 10:05.
Someone is here.
Can you let them in? There are a couple of people coming in, so just let's wait for 2 more minutes. Good morning. Good morning. Good morning. Welcome. Thanks for joining us on a Saturday morning. Ali, Mr. Ali? I'm good. Kiran?
Hey, Gandhi.
Thank you.
Hey, Gandhi. Yeah.
Akshay? Kiran. Nice to meet you.
Two of your name are.
Yeah, I'm actually facilitating this, and Gandhi is going to walk us through the context engineering aspects. All right. Okay. We'll begin. We have around 9 people online. So everybody is getting a YouTube stream as well, and also Zoom if people are in. If you want the YouTube stream, I'll share that with you in a second. And even we'll put this YouTube on Emerging Tech Hub, and also Gandhi will share on his own YouTube channel, right? So I'll just give you the kickstart, and from there Gandhi will pick it up. So as you all know, my name is Kiran Adimatyam, and thanks for making time on a Saturday morning, early in the morning, to come by. And everybody has been talking about AI, and since last 2 years after ChatGPT came in, it's been a exponential growth in that world, and we're all riding the wave, and most of us are actually using it, either personally or being forced to use that in the office, or if you're in an enterprise or if you're a startup, you would be utilizing the best of it as we go through. So what we wanted to talk today is the next or the latest wave of the advancements that are happening in the AI world with respect to AI agents and agentic frameworks, and how context engineering is going to help agents to do better, right? So this is a relatively new term that has been coined by Andre Karpathy, and vibe coding, context engineering. He comes up with these terms because he's into it. If you're not knowing who that person is, and go and check with either YouTube or his GitHub repos, or he has been the Tesla AI chief before he walked out, and he has his own startup now. He's working on a stealth startup and etc. So there's a lot of stuff that you can learn from him. And context engineering is the key thing that's going to happen. And every one of us need to understand what a context is in the AI world, and what this context means to better use the AI tools as we go through. So everybody uses AI. It's not like, we're not going to use AI, but how to better use it is what matters a lot for all of us. So this Emerging Tech Hub, I started like 1.5 years ago. We have like 1,500 members now, or 1,476, I think. The numbers are growing up, and we have a private WhatsApp chat. I've been inviting people that I know of. If you're interested, let me know. We have been sharing a lot of information there, and we're actually keeping the community abreast with the latest changes. And that's my main goal, to actually learn, share, and grow with each other. So having said that, so we have Gandhi here. Gandhi, if you want to come into the view. Yeah, so we have Gandhi here. He's from Capital One. He has been a senior engineer, and he's like hands-on most engineering folks you can find from Capital One. So he has been running this one of his YouTube channels, and also he has been doing these sessions for us. So kick it off, Gandhi.
Okay.
Can we take the picture of this?
Yeah,
Yeah,
go
please.
ahead.
Yeah. Thanks, everyone. Thanks for joining. I know it is Saturday morning. Okay. You guys all come here, so it should be highly motivated people, who's coming on a weekend morning to learn something new. Thanks for joining. As Kiran introduced, I'm Gandhi Raketla. I'm a senior manager for solutions architecture at Capital One. So today, this is the agenda for today's session. We'll just kick off with Kiran did. We'll just quickly talk about what is the context engineering is all about. Okay, and then we take a quick break. Then there are different context engineering strategies like context to loadout, and then context offloading, context pruning, and summarization. For each one of them, we just don't talk about that. We'll build an agent and see how we can actually apply this strategy in that agent. So we have 3 different agents for each of the scenario, and we are going to build agents. And we are also going to quickly touch base on what is AI agent is all about before we actually get started context engineering. That way you have, even if you don't know about AI agents, you have some understanding of what agent is all about, and then that builds you, again, as I told, context around agents. Okay. Okay. So you might seen this joke, right? You have a programmer husband, wife asks him to get me a loaf of bread. If they have X, get dozen. So this guy gets 12 because if condition, right? So it's something like, what is missing here is the guy didn't understand the context properly. So your agent is something like this. If you don't give a proper context, or if it misunderstood your context, it is going to behave something similar, right? So let's first see what is agent is all about, right? So we've been using LLMs like ChatGPT, from more than 3 years. So what is agent is making is it is taking you from giving you the data, giving information from action. You can go to ChatGPT and ask it, can you check get me the flights from say Dallas to New York, okay, on these dates. It can give the information, it can optimize everything, but it doesn't book you the flight ticket, right? Similarly, the agent is taking an LLM which is learning from the data, generating answers to place where we can actually take action on that. Like you could have an agent that plans your itinerary, that books your flight ticket, that books your hotel, that plans your itinerary based on your interest. And then maybe it is the more you use agent, it is learning more about you. Just like Netflix is learning about you, the agent is also learning more about you. It knows that for example, if you are using some agents to you buy something online, or it knows your travel patterns, so it can suggest you based on your travel patterns, based on your food preferences, like what type of person you are. It can suggest you activities. Suppose if you are something who like adventures, it say, hey, when you're going to New York, you should try these activities. You should try, if you're like a sports guy, it knows that, hey, there's some game is going on in New York, this, when you go there on this date, it suggests you that. So it is taking the, you have the LLM is all about the knowledge, agent is all about putting the knowledge into action, right? So we are going from a knowledge to an action, which can, where the difference is, you can ask me like, the same action can be done today by a lot of other applications, right? The what is missing is that the reasoning, the judgment capability. The agent can reason over, it can take action, it can reflect on its action, and again adjust its reasoning, its action based on that. So this reasoning, action, thought, the life cycle is what agent brings into from a traditional applications, right? So we'll see like what is inside AI agent that is actually helping you to do this. For example, take same example. If you say plan my 3-day Paris itinerary, you ask for an agent which is sitting in the middle. The agent is having 3 things. It is able to understand your query, and then it is able to reason over it. So it's something like if you actually see build a React agent, if you see the the logs when it is how it is thinking, it will say user is asking for a itinerary. So that means I need to first check for the flights. But to check the flights, what do I have? Okay, I have a flights API available with me. Let me use that flight API to book the flights for the user. Now I should also book the hotel for the user. after I think about the flight, I should book the hotel for the user. Now it also has got a hotel booking API. Now it goes and books a hotel. And then I need to check how is the user calendar, like what type of activities he has planned in the days where he's going. Then I have a calendar API. Apart from this, I also need to think about the internal memory I'm having. Like the user is talking to me regularly. I know this user food preferences. I know what type of user he is. Based on that, the memory what I'm having, which actually we are going to see how the memory knowledge graph, which can be built per agent. I'm going to show you a ZEP memory where we can build a knowledge graph around that. It can get the data from the memory, and then it can actually plan your itinerary, plan your activities, plan the restaurants where you eat, everything. And same time, an agent is also talking to other agents. It is not like one agent. Maybe I have a local event agent hosted by someone else, and this agent can talk to that agent to find, hey, what are some events happening in New York or maybe in Paris this weekend, or maybe the dates the user is going. It can actually get the information from that agent and add it to the context. So this is where we are having Google ATA protocol, which helps you to one agent to communicate another agent. And apart from this agent is also talking to other knowledge bases. You have a lot of, maybe you have access to user emails, you have access to user chats, maybe there are a lot of other external data stores which are available. So agent is also talking to the knowledge data stores. And at the same time, this requires some type of a guardrail. I cannot suggest something to the user. I should be, over promising something or giving some personal information. So that's where you're having guardrail. So this is where the agent is functioning. So you have the user query coming in. It is doing the reasoning on the user query. It is used, and by doing the reasoning, it is understanding the goals. And then based on the goals, it does the reasoning, it does the thought, it does the action, it reflect on that action, and then see like whether am I need to do something more than what I have done right now. And then this reasoning, this thought, action, reflection drive cycle goes on in a loop till it reaches a point where it knows that I got all the information. Now let me go on, take an action, or maybe suggest something, answer the user question. So this is about agent. Now, when it comes to the context, like then today's focus is about context engineering. If you see like all this while, when we are talking about the agent, something is very important happening is using context, right? It needs a context about the available flights. It needs a context about available hotels. It needs context about user preferences. It needs context about what is happening on weather data, right? So much of information the agent is handling while it is doing this thought life cycle, reasoning life cycle before it comes to decision. That's where the context is all about. So next, so far we just saw a quick overview of what AI agent is all about. To summarize, agents are taking us from LLM to agent is all about simply answering the questions to taking actually action on the user request, right? And we have seen what is inside AI agent, what is the AI agent ecosystem looks like. Next, we will see what is the context, or you might have heard this term about context window or context length. So what is the model context window? So context window can be broadly categorized into three things. One is hey, someone has come and they need to. So model, the context window, we can broadly categorize into three things. One is instructions, second is knowledge, third is tools. Instruction means all the prompts you are giving, all the few short examples you are giving is all part of the instructions, right? Same thing like, troubleshoot me this error, or book me this ticket, or maybe take this action. These are all instructions we are giving to the model. Next one is a knowledge. Knowledge could be your internal data stores. It could be if you're building an agent for your to troubleshoot some issue, it could be all your Slack messages which are being exchanging. It could be your Confluence pages. It could be some internal data source you're having, databases you are having. It could be structured, unstructured data, everything. That's what the knowledge. And then the tools. Tools are nothing which agent uses to take some action. If you want to, as I told in the previous example, if you want to book the flight, I require a flight API. If I want to book the hotel, I require a hotel API. If I want to check how is the weather in this city, I need a weather API, right? These are all the tools. Now, all these instructions, the knowledge, the tools are becoming part of your context which agent is using. Okay, so it is, to give an example, assume you have this student going from morning to evening. He might be going to different classes. He starts with, say, a maths class, an English class, a physics, chemistry, science, social, everything. So in each class he's getting a lot of context, lot of knowledge. Everything is there with him on that day, right? That's what the context is all about. Basically, similarly, an agent is also having lot of instructions, knowledge, tools all put together becomes the context for that particular agent. Okay.
Gandhi, one question, or maybe just clarification for you. When you talk about, say, the flight API, I was thinking initially of that as more like the action endpoint. So it's not really in the context of booking the API or booking the flights. But then there are two parts to that, because the first part, and that's why I was trying to kind of contextualize it. First part is I need to have the context about flight information to be able to figure out which is the right flight to book. And when I actually book the flight, I might use the same API. At that point, that flight API is not a context. It actually is the action that the agent is taking.
Yes, yes.
So similarly, how do you kind of distinguish those things? Like, because you have something which is part of context, but it's also part of your actual action.
No, actually there is, that's a good thing about beauty of our when you build agents. It is not very, just like same thing if I have done in a regular like I'm building some microservice app, some flight, travel app. Same thing I have done in a sequence manner. I first invoke flight API, then get the results, then I use the same API to actually book the flight, right? I go in this particular sequence. But when it comes to agent, it is not deterministic system. It doesn't go in that sequence. It basically takes an action based on that particular reasoning cycle. Okay, let me take a step back, explain you take same example. The way agent works is you ask it, plan me 3-day itinerary for Paris, right? So in the first reasoning cycle, agent sees that question. The reasoning it will do at that time is, if you actually see the agent reasoning logs, user is asking me to plan a 3-day trip to Paris. So first I need to go and check the flight information, right? Now it's for me, then that is a reasoning still. Then it takes an action based on reasoning, says that, okay, for this reasoning, I need to take an action called invoke a flight API, right? Now, assume that user is asking only for a flights. Now it took an action. It took an observe, then it observes on that action and says, okay, now I got the flight information. Maybe the action the way you might have configured agent is that as the user, present him the options. Okay, and if he says yes, then go and book the tickets, right? So then you could have some human in the loop is coming up. Then it might present at that time the agent action, next action is that present this option to the user, right? Now agent presented 3 options. User said option number 1. Okay, now when the user entered option number 1, the reasoning life cycle now goes, now user is chosen option number 1. So now I need to use it for this option 1, I need to book the tickets now. To book the tickets, I might need to invoke this flight API, but when I'm booking, I'm using a different API call now. I'm not just sitting fetching the values, I'm booking. Okay, so it is using the same flight API, but in the context for that flight API is different. In the first reason cycle, it was actually checking what information, it knows that in the context for that flight API is to get information. In second cycle, it is using in the same context window, it is using same flight API, but to take an action.
Yeah. So would it be a fair understanding to say that the input to the decision model is the context?
Yes.
Anything that's given as the input could be instructions, knowledge, and tools. Everything is basically an input to the decisioning process, and then any action taken is obviously just action. Right? It could be a context for the next decision, but for this particular event, it's just an action, but it's not part of the context.
No,
How do you distinguish? Basically, how do you distinguish what is context versus what is not?
Okay, anything which agent required. Okay, if you see, right, no, I cannot clearly distinguish between, okay, both are part of context only. Both are actions only. One action could be to display the flight. Second action could be to book the flight. Both are actions only, but only thing is that in the first action, it requires a different set of context. In second action, it requires a different set of context. Maybe I'll do one thing. I have a next slide actually example about that. Maybe let me walk you through that. In fact, same thing we are talking about. If you see, there is something called context explosion. What happens is, say you have a prompt, okay, generate a sales email for a company X. Okay, this is now the context of the model is very less. It doesn't have anything at this point. Now it goes to thought lifecycle 1. So user is asking me to generate a sales outreach email for a company X. So what I should do, first I need to search for this company in the internet. So it will just goes and do web search, right? When it does a web search, the context is having company news, website data, and everything. And next thought lifecycle, it will do, now I have the company information. Now I need to generate a sales outreach email for this particular customer. I should have access to my company internal database to know what products my company serves for this customer. So I go and hit my internal database, which has got information about all my company products. Now your context is having the information about the company, information about all the internal products of your company, right? Now in next thought lifecycle, it is actually taking the company data, maybe it is all next thought life could be that, okay, now I should do some market research, whether or maybe I should do some research on what should be the email I need to compose for this customer, okay, which will be useful, which will combine both the research I have done and then my company internal products information I am having. That could be in thought life cycle 3. Now in thought life cycle 3, it is using the context from the both things, like from cycle 1, cycle 2, both things are merging, and it is using that information thought life cycle 3. Now thought life cycle 4 is actually, it is drafting the email, right? So, and then cycle 5 could be sending out that email. In each of things, if you see, the context is actually, it is appending all the information to context. For every action is taking, whether to do research, it has when it is doing the research, what it has got in the context is only company name, right? When it is doing getting internal data from the company, from some RAG application, something database, what it had in the context is the user query, the internet search it has done. When it is composing the email, it is having the user query, the internal data, the web search, and also the the market research it has done. So every time you see, the context is keep on growing. It is like, assume that you are going for a big conference, maybe some some conference by you are attending some 10 sessions from morning to evening. Like every 1 hour there's a session attending. What is happening? One session they're talking about AI, second session they're talking about some data engineering, third session they're talking about DevOps. You are actually getting the knowledge. Like by end of the day, if someone asks you to hey, summarize your conference for the day, obviously you will be overloaded with information, right? You have a lot of information at your disposal, and maybe depending upon, sometimes even you might miss something. Maybe before lunch you attended one session, maybe you might miss the information about that session because you have a lot of information in your memory at this moment. So, but what if you're actually properly organizing this information when you go for conference each time? Like you went for session number 1, you make some notes, you stored somewhere else. Session number 2, you went, you took some notes, you put it somewhere else. Now end of the day, someone asks, hey, can you summarize your day? You will do amazing job because you have properly organized your context when you went to each session, right? That is what the context engineering is all about, where when the agent is running like multiple thought life cycles are going, it is collecting the context, how better we can organize this context so that agent has got very information which is relevant for that particular task in hand.
Yeah.
Hey Gandhi, I have a sorry, one question that Krishna has. Knowledge can be past conversation history. Is that right? I mean, knowledge can be past conversation history.
Yeah, of course, yes. Knowledge can be your, as and when you're talking to the agent continuously, you are actually building the knowledge graph about user. In fact, we are going to see that in actual demo. Like I'm building a nutrition agent where every time I ask the question to the agent, it builds a knowledge graph behind the scenes. It is able to connect every piece of information, every word you are talking. It is able to extract the entities from your conversation. It builds the graph, right? So we'll see that. So before we go in details, I want to point out a study done by the Microsoft and Salesforce where they called LLM get lost in multi-turn conversation. So what they have done is they measure two variables. One is called unreliability and aptitude. Aptitude is something like what is a model's best case performance. And unreliability is the difference between the model's best case performance and the current performance. So they have done this study where they studied done on all the GPT 4.1, Gemini, Claude, and DeepSeek and everything. What they've done is they are given a model only one prompt where it says, okay, please generate X and I need this requirement 1, requirement 2. And then you can see that whenever they're having single turn conversation, model performed really well on both aptitude and low unreliability. But on the right side, if you see, when the multi-turn, like they keep on asking the questions, like, do you mean X, sure thing, like, it is going on, the model aptitude is going down, unreliability is increasing. So what it says, the reason being, as I told, same example I told, you are going to a conference from morning to evening, you are having all the knowledge of 15 sessions happening from morning 9 to evening 6 o'clock. If someone asks you to ask a question in the evening, you will not be able to answer correctly, right? Because you are dumping everything in your memory. Your context is growing. So that's the reason you need a better way to organize your context. That's what this study is showing here. Okay, I just want to put out this tweet by Andres Karpathy. That's where he says, in fact, I like the sentence where he says, context engineering is a fine art of, having delicate art and science of filling the context window with just the right information for the next step. That means in having a multi-turn conversation, if the agent is, as I told, same example, I want to go back. If agent is booking the flight ticket, do I need to have all the information about the weather, the hotel, everything at that moment? It just need only that information. Just like, agent is like human being, right? If you are going for a meeting, someone gives you a 500 pages of meeting notes. Is that really required? You might be having someone is taking the meeting notes with a customer. You working with the customer for the last 6 months, so you are having a weekly meeting with the customer. There are meeting notes taken every week. So you are going to meeting tomorrow. Someone gives you the meeting notes from all the 6 months to you in a document. That really helps you. Rather than if they give you meeting notes which is required for the agenda of the today's meeting. So today we are going to discuss about some future plans or some troubleshooting some issue or some other roadmap. If you give only that information, that is very more useful than actually having all your information. That's what he's saying here. The context engineering is delicate art and science of filling the context with right information and the next step. In fact, this actually I'm only showing a part of the tweet, and he actually elaborated more about that. In fact, you could see yesterday evening only, I was watching one podcast by Andres Karpathy, and somebody put up in Twitter, actually. Sorry, I'm still used to the Twitter.
Everybody's using it.
Yeah.
It's from Dwarkesh Patel, right?
Yeah, Dwarkesh Patel. Yeah. So yesterday night I watched him. I couldn't watch fully, but I watched first half an hour, I guess. One thing I liked when he said, the Dwarkesh Patel asked him, you said that one company put up a statement saying that this year is going to be the year of agents. And then Andres Karpathy told it is not year of agents, it's a decade of agents. The reason is he said this whole ecosystem, this whole agents are still evolving. They need to. We are still nowhere near the perfection that now I have the agents, they'll take care of everything. There is still the challenges of hallucinations or agencies, just like we said recently, a report by a news, right? Goldman Sachs, right?
Australian.
Yeah, Deloitte, Australian government, they paid around 440K report. It is having a lot of hallucinated content and wrong references. So
Yeah, it's not only the hallucinated content, the content that actually got generated has been passed as a report from the
Deloitte.
Deloitte guy.
Passed it and submitted it to
Yeah,
the government.
submitted to the government. So that is
Coming.
exactly.
Information. So that's what is one. Now next we'll do one thing. Next we'll see there are, but now we are seeing like context is important. So let's summarize what we are seeing right now is we know that context is what is a collection of your instructions, the conversations, the data, the tools, output, everything is part of context. Now, what can go wrong with this context, right? If we know like what can go wrong with the context, then we can think about the strategies for each of them. So in next few slides, we'll think like what can go wrong with the context. In fact, what I'm putting now right now is inspired by another blog I read where he put up all, I'm going to share the blog also, where he put up all these 4 ways the context can go wrong. So one is, the first one, the context can go wrong is context poisoning. Okay. So I'll put a simple example. Say you are having a medical chatbot, right? You are asking it a questions. The patient comes and says, I'm having headache, sore throat, and no fever. Okay, this is input. But somewhere when agent is processing, the word no gets dropped. Now the input it is having is headache, sore throat, and fever. Somewhere summarizer dropped the no. During some action cycle. Now every time the agent is thinking, now it is all the while in this thought life, it is thinking that he's having a fever. Now it is saying since you have a fever, it assumes something wrong. It may be flu. Basically a wrong data entered your context, then that is impacting your decision, right? Just like human beings, you go to doctor and you tell him that I don't have a fever. Maybe doctors didn't hear properly. He thinks you are having a fever. Then obviously he's prescribing a medicine for that. Same thing is happening when you putting a wrong stuff into the context. It is again same as garbage in, garbage out. Right? Same old principle of garbage in, garbage out. Same thing like in context also. So, but we'll see like what could be the scenarios where something wrong could happen, right? So, for example, whenever user enters this one, you are actually doing some web search and getting some data. Okay, when you get in the data and then after getting data, we are asking the agent for summarize before going forward. During summarization process, some words might get dropped depending upon how you construct your prompt. So then the agent is using the wrong data for his reasoning. So that's what the context poisoning is all about. That means you have a wrong data entered into your context, which is impacting the model's reasoning capabilities. And reasoning is the core of an agent. When the agent reasons wrongly, it takes a wrong action and then it thinks that that action is the correct one. That's a problem with the agent. Agent fails, but they fail very confidently. And they will not even tell you that why they are failing. Right. So that's a big challenge you're having. That's when you're having observability tools in place. You need to have tracers, you should have experiments, you should have data sets, everything. That's a big topic altogether. But that's what we need to be mindful that when we use agents, they fail silently without even telling you. Okay, that's a problem.
Yeah, even with the LLMs, we all know that it hallucinates. It will never say no for an answer. It will give you some answer, whether it's right or wrong, it's up to you to decide. So the same thing gets carried over.
Yeah. And next one is the context distraction. Okay, what happens is, say somebody is you want to ask the question, you're having some a fintech agent, you're asking this question, should I buy this alpha tech stock this week? If it is having limited context, it might give you good answers. So what you are giving some knowledge to the agent. Maybe something is going wrong with that way you're getting the data. You are giving something about some trend, some market crash, some recession, some everything you're giving. You're dumping it with one, then it get distracted. There is some study they have done. The models basically will perform well. Usually take the content available in the top. They tend to ignore the content which is in middle of the context. If you give a huge paragraph and then somewhere in the middle of the paragraph some important information is there, model might miss that, because that's how they behave. This is study being done on, I think, Llama 70 billion parameter model, where they have done that. The study they have done where if the context which is in middle of the context, we get lost. That is called context distraction. That means model is getting distracted, with information. Just like you give a student bunch of information just before he has to go for a math exam, he has to study only for this particular chapter in calculus, but instead of that, you teach him algebra, you teach him, everything starting from, high school. Obviously, he will not do good in that exam tomorrow, because he's getting distracted by that particular context you're giving.
This is an interesting thing.
Yeah, hold on 1 second. Let me actually get this so that everybody on Zoom can also listen.
So, distraction, like we get distracted. But if you give it more relevant.
Can you hold on 1 second? Can you mute? I just want to have people listening to his. You can repeat the question.
Yeah, I can repeat the question. Yeah.
Question is really, you said more context is not equal to more intelligence, right? But does it mean more relevant context equal to more intelligence?
Yeah, you hit the nail. Yeah, that's what we are going to do. Like, how do we get the more relevant knowledge? In fact, I'm having a demo on this similar knowledge, where we are going to get all the IRS documents. Okay, like 5 big IRS PDF files I'm going to load into RAG, and I'm going to ask a question. We'll compare the difference if you don't prune and summarize the context without prune and summarize. What is the difference? We'll show. Actually, there is a demo on this. Pretty much everything I'm showing, we have a demo in the coming slides. The next one is context confusion. You might think that it is very irrelevant to context distraction, but it is in terms of, as I told, adding too much information to context sometimes overwhelm the model. They might start invoking the tools which are not relevant for that particular ask. So, you might want to ask, why did the revenue drop this quarter? And then you were adding too much context to the model. Model might think maybe based on this content, I should invoke some, HR API, some leaves API and everything. Basically, the context distraction not only, it is similar to context distraction where you are overrunning the model context, but here the model is again invoking it is taking irrelevant actions. Okay, in first case, it depending upon the overall context, its reasoning itself is getting messed up. But in this case, it is taking the wrong actions based on the relevant context. So other one is context clash. That means model is having two contradicting information. Same thing example, you say that today weather is sunny and clear, then after some time you get an update from radar that a thunderstorm detected. So model is having a information which is irrelevant, which is contradicting to one another. For example, something similar, right? You are going in a direction, somebody is sitting next to you, say, hey, turn left now, and then after a few minutes you say, no, take right, no, take left. What happens to you? You get confused. You don't know what. If you take a left, it should go straight, take a right, you don't know, right? That's what the context clash is all about, where model is getting two conflicting information that is actually messing up the context window. And then obviously, but what we should realize by now is everything model does is based on the context, because any reasoning, any action, any thought model is taking based on the context, which is information available. So it's just like if we manage, it is basically, I would say, a lot and we can use a big word context engineering. It is nothing but a common sense, like, just like human beings. We should think like model, like agent, like a human being. Obviously, sometime in the future, you will have agent as one of your team members. So if you go to a Slack channel, you will have an agent. He can ask, hey, what happened to this? Obviously, you treat him like your team member, and you treat the team like when you give a team member, if you give unnecessary information, obviously they will not perform well, right? If you're having you could have, same thing is going to happen. Obviously, day is not far away. You go to work and then you're having a team Slack channel, you'll have a couple of agents.
Yeah.
One is a DevOps agent, one is, a question answer agent, one is a coder agent. So you'll be talking to them.
That is actually happening, and Microsoft is, they have been telling this from last year also. There's an AutoGen framework that they came up with. They're expecting millions of agents running in any enterprise that, in the coming few years. So every agent, every process, basically all the agents will be taught the processes, and those processes are so important to be learned in the right way. This is because that's the major reason we are having this context engineering aspect. When you're utilizing those tools, somebody else did it, or you could be part of that team who are generating those agents or creating those agents. These basic principles are very much required to be known. Otherwise, you'd end up having an agent that doesn't do the work that you want it to do, right? You're like creating a junior developer that's useless for you. So you have to create another one. So at some point, we'll all be creating agents. So the better we know how to create the agents better, but we'll be utilizing those for our purposes.
Actually, we'll see one example. With same example I told, in the next demo, I'm going to give you something that where you could have a DevOps agent as one of your team member in the Slack channel, where you can go and ask, hey, my instance is failing, my database is not working, what happened? Then the agent can actually answer the question to you. Maybe we'll show that demo actually. Now that what can go wrong with the context. So you could have a wrong data entering the context, poisoning it. You could have a lot of unrelated data entering the context, making context distraction. You could have a conflicting information entering in the context, maybe confusing the model, right? Now, some of the 6 proven tactics to break the, fix the context is RAG. Everyone knows about the RAG by now, which is retrieval augmented generation. Other context is called tool loadout. So what does it mean is that we're going to have a demo for each one of them in the next 10 slides. In tool loadout, basically what we're trying to do at the core, what we're trying to do is a lot of times an agent will be dealing with hundreds of tools, right? Someone was saying like Manus AI agent, it is having more than some 500 tools it might be using at any point of time. Okay. So now instead of giving all the tools to agent, okay, you give only the relevant tools to the agent. We'll see that in action now. Okay. And then that way model will have less information in the context. Next is context quarantine. So you isolate the task into separate segments. The example is that I don't have a demo for this, but in fact I have a demo. I'm not sure I have time for this, so I didn't plan demo for this. Something similar to this. For example, you have a supervisor agent. As I told in the example I told, you need to draft a sales outreach email for a customers. Your question could be, draft me sales outreach email for healthcare customers in Texas interested in my observability product, right? This is my question. Now you need multiple things here. First of all, you need an agent which will get you who are all the healthcare customers in state of Texas. And next, I need agent which will do the market research and trends. What are the recent trends in healthcare? Maybe you're asking the question like healthcare startups. Okay, now the recent trends in the market for the healthcare startups. Okay, and then I need another agent which knows about, as a company, I'm having hundreds of products. Like which of the products are relevant to healthcare customers? I'm having this agent. And then I have another agent which can take up the market research, which can take up the customer information, which can take up the products, and it can come up with a strategy to compose the email. Okay. Next, I have another agent which is good in English. It can actually compose that email, right? So I'm having like 7 agents. Now, the one strategy we could do is we could have supervisor agent, which will actually communicate with each agent and then give this agent only the relevant information. So for the market research agent, it will gives you information hey, you need to do research on the healthcare startups in Texas. That's it. Next, for the next agent, which is the say for example, products agent, it will give instruction. Hey, you need to get the products relevant to healthcare customers in our company, right? Then you have another agent to give instructions where can you compose a strategy for this customer based on this data, based on this product. You want to have not a cold email sending blasting everyone. You want to have a personalized email relevant for that company, right? So you want to have that one. So now you are having one agent deciding everything, sending tasks to all of them, so that each agent has got a context which is quarantined. They don't have a lot of other contexts, right? That's the one strategy. Next is context pruning. As I told, you are getting a lot of data that we are going to see this in action. So for example, I'm having an IRS data. I'm having some 10 PDF files. Someone asks you what all the tax benefits credits I get, for 401k, or maybe something like, different between 401k or Roth IRA, something is asking. Now, instead of dumping all and when I go and search in my RAG, it gives me some 25 pages of information available in the IRS website, but not all of them are relevant for this question. I need to remove the information which is not relevant. In fact, context pruning and context summarization, they are somewhat similar. They are not exactly, in context summarization, what we do is we remove the relevant information and summarize only the required information for the model, right? And then context offloading, we are also going to see a demo of this. This is where, as one of the user asks a question like, conversational memory, right? You are talking to the model continuously. That's where you have to leverage something called model memory, which will, you keep some of the information in model memory, or maybe something, we have two strategies called scratchpad memory. Again, when I think about the agents, I think of context, think like human beings. Like when you go to meeting, you take a notebook. Okay, of course, nowadays no one does that because everything summarizes.
No, but I'm glad to see a lot of people actually.
Yeah, a lot of them take notebooks. Okay, sorry, that's good observation.
That's good.
Good observation.
Right is what you.
Something like when I'm talking, you're noting, jotting down a scratchpad, right? Same thing we do with the model. When the model is taking one model has taken action, it has done a web research. It might require that information sometime down the line in future. But instead of putting them in the context right now, I just go right on a scratchpad, right? To give same example, the market research agent is done the market research. It has got the data. The next agent is the one which goes and sees which products are relevant for this customer. It doesn't require market research, that agent, right? So you don't have to overrun the context with that data. You can write it somewhere else. Next agent, which is composed in the email, that requires this information. At that time, you pull the information from the context and give it to the agent. You are actually trying to limit this, what the context is having depending upon the action. That's what actually, if you see, go back to Andres Karpathy tweet, maybe let me go back here again. Actually, this really, in fact, I like this person because he summarizes, he doesn't talk anything, he very focusedly, he tells something. You can see here, it is art and science of filling the context, right information for the next step. For that movement, for the action you are doing, what context you require, give only that information. Because this is becoming increasingly important. The context nowadays is not just the text, right? If you see Gemini now, it could have multi-model context. So that means I can take a picture of this and then ask a question. Now my context is having the question user is asking, the picture is uploaded, and then a video, he uploaded. In fact, I was few days back, I was there in a Snowflake conference. They were showing me a demo where they are uploading all the customer conversations with the agent they're having for a product, audio conversations, right? Hey, I'm this new product, I'm having issue with this product, I'm having this issue. And then you can ask a question. The agent can actually now has to see the audio conversation which are happened. And then it should see the product information which is there in your database. It should see the customer reviews for the product and give you the answer, right? The context is just not a text. It is audio files, it is a video files, it is images, everything. So it is becoming really complex. So I think at this point, I'll summarize and we'll take a quick break, and then we'll go to some of the context, some of the demos where we showcase, we'll see them in action. So to summarize, we saw what is AA agent, which is taking us from LLM to an action. Okay. And then we discussed that what is a context window, which is nothing but the collection of instructions, tools, knowledge. And then we have seen the how the context can blow up when you're having multi-conversation, and then what can go wrong with the context, like context confusion, context distraction, context conflicting context, and then we are seeing the strategies. Now in the next coming slides, we are going to see the demo of tool loadout. We are going to see the demo of context pruning and summarization. We are going to see the demo of context offload. Okay, I think we'll take a quick break now, but I can also take some questions if any questions.
So when you say the external memory, is it similar to cache?
Yeah, it could be cache.
Can
It could,
you repeat the question so that people?
yeah, the question is external memory, what all is the same as a cache? It could be cache, but it could be also agent memory tools which are having, for example, if you're using LangChain, it is having LangChain memory, and we're having Zep memory, which will build we are going to see that in action now. I don't know. Okay, yeah. It could be anything, or it could be your own. It could be Redis also, like some caching database. It could be anything else. Yeah.
We document.
Okay. Can we take a quick
Okay,
break?
so how long is the break? 10 minutes?
Yeah.
I think there are like a couple of questions. 1 second. Before we take the break, there's one question from Leela. Is there reroute techniques to avoid to build multiple agents based on the context and users? Trying to understand the question. Is there
Maybe I'll jump in.
Is there
So for example, I want to build an agent for me. I want to build an agent for Satish or one for Gandhi, right? So based on the context or based on the user, can we able to reroute and based on the context instead of building separate agents for each person?
Yeah, that's a good question. So you were saying that based on the context, can I reroute the request to different agent, right?
Yeah.
Yeah.
I think that's what I'm saying. Yeah.
Okay.
Yeah, I don't want to build like individual agents. Like based on context, one agent should act and serve everyone.
Honestly, I'm not really aware of any techniques. I believe this is more of a building something, maybe some customized solution on your own, but is there any established technique for that, which I'm not aware of it? But what I could think of is something like, if you're using something like a LangGraph to build your agents, obviously you could have more control over how do you route your request. So you could have that when you put the a router node in the LangGraph, that router node could have the information. You could actually have an agent which will route the request based on that context. Maybe we can have that.
Yeah, he's getting into the agentic architecture patterns that it falls into that category.
Yeah, that's a good question.
Yeah,
but what's the use case? I think what's the use
so
case?
that's what I was trying to get to, right? It could be one of those agentic architecture patterns where one agent could be an orchestrator agent that actually manages the other smaller agents, where you have all the context with the orchestrator agent only. That's one thing I can think of. Right?
In fact, I'm not sure who is the person who asked the question. Is it Leela?
Hi, sir. This is Leela Karnam.
Yeah, I guess we are in the same college, I guess, right?
Yes, sir. Yes, sir.
We went to the same college.
Oh, you?
He's my junior in the college.
Yes, sir.
Okay. Maybe one way I could think of is, in fact, one of the example I'm having is when user asks the question, I have an agent which will determine the intent of the user. Like, what is the intent of this request? Depending upon the intent, I'll route to a different, agent. That could be one of the examples.
Isn't it similar?
That's your
Okay.
Yeah.
LLM.
Yeah, maybe I'll connect with you offline. Thank you, sir.
Yeah, it could be. I didn't hear what he said. What were you saying, Leela?
No. I said maybe There's like deeper discussion required. Maybe I don't want to.
Yeah, I think it will get into the architecture patterns and how we manage the agents, but your question, you're saying LLM does it automatically? Is it?
I mean, it's your, I asked one question now, in another question later, completely different context.
Right, right.
So that's your, it's an LLM, or he's asking about an LLM.
Yeah,
And end of the day, for everything we do, right? We are again using LLM for everything. And if you say contest pruning, contest summarization, you're using LLMs only there for everything. Even for contest offloading, pretty much only thing is that how we use is what the strategy is all about.
Yeah, I think the, if you look at traditional applications before LLM, a lot of what you're talking about, an orchestrator or whatever it is, it's all workflows, right? Like we used to build workflows, right? In the old world. I think the big difference now is your LLMs will give you reasoning, context. So it's a lot more, you're offloading a lot of your own thinking and all the dirty work you have to do to these agents.
Yes,
That
you are.
actually help you plan, do whatever it is, and ultimately give you like plans.
Yeah.
I think that's the big difference. I mean, to think of old patterns and to force fit those patterns into the current scheme of things is in many ways not the right way of looking at these problems, at least in my opinion. Because this gives you a completely different way of building stuff,
Yes.
right, which we never had before.
Again, as I told, right, a lot of this, my lessons learned is a lot of the strategies, right, is kind of evolving. I think people will experiment this, they'll burn their fingers, they'll again adjust this one. That's what happened for us. A lot of, if you're, I was yesterday also selling, like, if at all people who were there in the .com era, people were trying something, they know that it didn't work, new frameworks came, new, patterns emerged, and then eventually we'll reach there. A lot of things we are doing right now is kind of experimentation, I guess, somehow.
Yeah, a lot of it is still unknown.
Unknown.
Yeah, agree, 100%.
You can, I mean, I've been building stuff for the last 8 months. Right? And it's fascinating how you can actually build things so quickly now. Right? I mean, I think the time to market is shrunk dramatically. You want to build new features into a product, it's not, it's days. Like literally, I can think of a feature in the morning and have a prototype ready by the end of
yeah. It's the question is not about how fast to build. Yeah, you can build it fast, but how fast to distribute and scale up. Actually, distribution and the scale are the most important factors these days. Because anybody can do anything, right? If you have the right way to prompt, you can create an app pretty quick. And every one of us is competing for that space, right? So it will become more congested, and if you want to stand out, you need to have different mechanism and other things.
Okay, I think we'll take a quick break now.
There's one question, but I think we'll come to it a little bit later. It's about
RAG, right?
RAG, yeah.
So I think we have, in fact, I have a demo coming up for that question, Priya. We can show you in the demo, like a real example of that. Okay.
Okay.
Yeah.
So we'll just
Thank you.
Thank you.
Nice meeting you, sir.
Yeah.
Yeah.
Will can you put the audio off for can you put the agenda on so that we're actually we were supposed to take 10:45, but we were
We
yeah, we got last one discussion. Yeah, thanks for coming, man. Good to see you. Actually, there's water. I didn't know how many people will come, so I couldn't get anything to eat, but we have a bottle of water. I was trying to see if I could get some water. That's it. It's great. That's it.
They run the risk to you ourselves. But it's
Okay, we are back. Okay, 1 second. Okay, next we are going to see from now on will be mostly demo. I'll also do some code walkthrough because sometimes if I show you the code, if I show you the how it works in the log, we'll better understand the whole the thought lifecycle agent is having. So the first strategy we are going to talk is contest this tool loadout. Okay, what is tool loadout is typically when you are using any agent, you will have multiple tools. An average an agent could have 50 tools. Okay, and then there is a a study a research done using Llama 8 billion parameter model that whenever the number of tools increases, the performance degrades. So like they tested the 46 tools versus 19 tools. So the performance got degraded. Just to give an analogy, say you have to answer a question about finance. Someone asks you whether this particular question, this particular item is tax deductible, right? You are a CA, okay. Now someone gives you 30 books related to the all books, and 3 books are in that 30 is finance. So what you will do, you will go through each book, pick up the right book, and then you actually give the answer to the user. But it might happen, human beings are okay, but if you have same thing agent to do, it might pick up some 1 or 2 wrong books once in a while. Okay, you give philosophy, you give finance, you give some accountancy, you give some mathematics book, ask a question, you ask the question on the tax breaks, it might pick up some books related to accountant, and then it might think the data which is there in that might be relevant for this question. It might give a wrong reasoning, it might give a wrong answer, right? So that's what is happening. So what is the tool loadout is that it is addressing this problem of, I would say context confusion, what we discussed, right? Where you are giving the model lot of tools and some of the tools might be irrelevant, okay? But when I did the test, model still works. You don't see difference without tool loadout. Even if you give 50 tools, the model still works. If I give 50 tools and ask it to work, it still works, it gives relevant information. But there is also another aspect, which is your context length. Every time your context length increases, you are paying money for that. We'll see that context number of tokens, right? You are being charged a number of tokens. So if you have a option where you could have some 20 tokens versus 100 tokens, obviously your cost is going up. And then obviously the money you're paying is also going up, right? So to show the example, I built a simple DevOps agent. So what this agent will do is, when user asks the question, it will answer. It could be something like, my application is running slow, what is the reason? The database is not responding, like that. So it is having 50 tools. It could be some tools related to environment, tools related to database, tools related to the observability tools, everything. 50 tools it is having. Now we'll see the difference. We'll do 2 things here. One is that we are going to store all this tool information into a vector database. Okay, depending upon the user question, we pick up only the right relevant tools for that user question and then pass only that tools to the model. Now we'll also see, instead of doing all these things, we pass all 50 tools to the model. Okay, the response will be more or less same between both. There is no difference in the response, but it will increase your context window. It will increase your cost of the answering the question. So that's what we are going to see in this example. So to summarize, you will have an agent. User can ask a question. This agent is going to look into all the tools and then picking up the right tools. So what I'll do next is that I will walk you through some code related to this agent that way, and then we'll see this agent in the action. So this is your, the agent. Let me drag this one so that you have more space here. Okay. Now, I'm not going to go in details. We'll also see in the Langsmith UI, when you run the agent, the difference in number of tokens between the option 1 versus option 2. We'll see both of them.
Just wanted to talk about a little bit of the tools that you're using, like Langsmith.
Yeah, I'm going to use it. Okay, that's a good question. Let me first talk about tools. So here I'm having tools, like I'm having a database tool. So this tool has got a lot of methods, like get me the RDS health, get me my logs, RDS logs, RDS, for using AWS, it is RDS database. Do this action backup RDS instance. These are all different tools available, on the database. Then I'm having EC2 Kubernetes tools, which will tell me what is the status of my EC2 instance and how many instances are active. So you need to pay close attention to this part. Okay. So every tool has got information about this. In fact, this is what the agent is using to determine which tool to use. This is very critical part. That's why when you write a method for the agent for a tool, the documentation you give is very critical. More clear documentation, the docstring you put for that method, the better agent knows how to pick up this tool or not. Because agent is primarily basing his decision on which tool to pick up, which method to invoke based on this. Okay. Now what we are going to do is we are going to read all these files, and then we are going to chunk all this information, store this information into a vector store. Okay. And then we will use this vector store to retrieve the relevant tools. So we are having all these tools, monitoring tools, networking tools. Basically a tool, nothing but you can assume an API with set of methods, which will give you something. For example, if I say it will tells me check disk usage, will give me the disk usage for that particular server. Okay, right? Now, what I did is I have a Pinecone database. Okay, so we have an index. So we have indexed all these tools here. Each tool is having some ID, the category, what is the class name, the description, the parameter, the return type, the tool name. I'm having all this information. Now, if the user comes and says, my EC2 is not responding correctly, or maybe my EC2 is responding slow, my application is down, it will do a semantic search against this vector database. And it knows that for the EC2, for this problem, these are all the relevant tools. Now, we can actually do a little bit more on that. We can actually improve the relevancy by doing the re-ranking and then making sure that the data we are storing is properly chunked and everything. We can do all the things so that we are very close to the perfection of getting the right tools. Okay, so step one, what I have done is all the tools are being written here. The class.
There's like question is, are we on AWS is the question.
Yeah, this assumes
Yeah,
that you are,
Gandhi, like I'm a
What is AWS?
non-developer, it'll help if you just list out all the tools that you're presenting. Because
so-
I'm seeing it for the first time. It helps me, like if you just name the tools, because you're navigating between,
okay, sure.
Pinecone.
So,
I learned that Pinecone is a database, so that's how I'm learning.
okay, so the one tool you're having is called database tools. This tool has got a method like get RDS health, RDS logs, reset RDS instance. This is having all the tools relevant to a database. So if you're having AWS environment, if you're using RDS, I'm assuming that you're using, I should have called out that initially. I'm assuming that I'm using AWS as infrastructure. So RDS is your database you're using.
Okay.
You're having list. Then you're having EC2 Kubernetes tools. which are having all the methods. In fact, if you want to go through this, there is a GitHub repo, is open source, my GitHub repo. You can actually go through all this code in that GitHub repo. I can leave that in the comments in the end,
Yeah, just to add a little bit more color, right? I mean, I'll try to explain. So this example, what Gandhi is showing is actually depicting a DevOps agent in an enterprise world where people can utilize this agent to ask questions, figure out whether they have a problem, how much memory is there, how much disk space is there.
Yeah.
So for getting those questions as if like, I mean, if you have a DevOps team member, you would actually ping in saying that, hey, can I actually deploy my code now? Or do I have enough space to deploy my code into that particular server? So those are the tools that he has built. Simulating the agent, the person that you're talking to is nothing but an agent now. That agent would require these tools to be utilized to go back and check and get the answer back to you. So if this were to be an agent in an enterprise world, this is how it's going to get built, utilizing the internal infrastructure and other things. So that is the paradigm of the bigger picture, and now he's getting into the code.
Now I'm having monitoring tools to monitor all your disk usages, your CloudWatch alarms and everything. Then I'm having networking tool to check your DNS records, your firewall rules, your security groups, your VPCs, connectivity, everything. And then a utility tool for all your listing your S3 buckets, checking an S3 file, deleting S3 file, and all those things. So of course, this is all a dummy data, dummy information. This is not like real, but if you see all things, it returns only a dummy data, okay? Because there's only a demo type of a tools. Now, step 2, we have to store all this data into a Pinecone database, which is a vector data store, okay? I'm having an index and I'm storing all these things. There is a, just quickly tell you how it works with the vector database. Whenever you ask a query, it converts the query into an embedding. Okay, now it will go and search what are the matching embeddings in the vector database. Embeddings are nothing but the something like you are converting your data into a vector form where you can do some cosine similarity. Again, going into that is a different session altogether. But for now, you can assume that this is doing a semantic search to get the relevant tools. Now, before I go demo, I'll quickly walk you through the code because the time what I'm having, I'll not able to walk you through in detail, but I'll show you the relevant parts of the code. But if you want more details, this is also available in my GitHub repo. So here I'm using DeepSeek as a model. I'm initializing the model here. So I'll show you the tools. This is what I'm doing here, getting all the tools. There is a method in LangChain called this import method, conversion position only function to tools. It converts your API function into a tool basically. Now, this is the important method, select tools. It is taking the user query. It is going to Pinecone, retrieving the relevant tools, and then getting all the relevant tools for this particular user query. This method, again, you can enhance it, you can fine tune it, you can add something like a re-ranking and everything, so to make it more perfect. Okay, next one is, okay, let's walk you through now the core agent. Now, this is the agent we are having. This is our, the tool loadout agent. Now we can see that the tools, this agent takes parameter like a tools, like what the tools I'm passing, the LLM, the agent type, and this is a zero-shot React agent, verbose, and all this handle intermediate steps and everything. Then we are saying invoke and input query. The key thing you should observe here is the tools I'm passing is only selected tools. Now I built another agent which is not using this pattern here, which is a baseline agent. Here I'm passing the difference between the tools here is that here in this selected tools will have only the tools which are relevant for this user query. And in here, I'm passing all the 50 tools. Okay. And we will see the difference between, okay, let me run the code because it takes some time to launch the UI and then we can see this. Okay, while it is launching the Streamlit UI, Let me also walk you through the code.
So that Pinecone database has the metadata of the tools that the agents can utilize from, right?
Yeah. And then I'm having running the agent, then we could have the pass the whether you want to use a tool loadout pad mode or you want to use a regular mode. Okay. So
How do you determine what is the relevant tool for a certain action?
yeah, that's again, this is the method, retriever method. Okay. When I say retriever retrieve tools, you can see I'm passing the user query. And I'm saying, get me top 10 relevant tools for this particular user query. How it is doing? You are asking for my EC2 instance is down in AWS. It knows that the user has used the word EC2 and then instance. It is doing a semantic search against the Pinecone database. Now that gives you 10 tools, which are very close to the user query, I don't use the word close, which are semantically relevant to the user query. The key thing is semantic. It is not like a simple keyword matching search. It knows the, it is doing that. That's what you're doing. The cosine similarity between your query and then available data in the vector data store. It is getting the similar tools.
Is there any reason you're using top 5? Because it would.
You can use also top 5. I didn't find it. You can use top 5 depending upon how closely you want to control. I thought 10 would give me covers a broad range. I should not want to miss any tools. But even if you give 10 tools, agent will pick up only 2 or 3 out of them. It doesn't pick up all 10 tools. Okay. Even if you give 50 tools, agent will pick up the right tools. We are trying to reduce the context window, which will also impact number of tokens you are going to have. Actually, we'll see in the Langsmith when we run the both agents. I'm going to.
Isn't it like increasing the context?
Yeah, it reduce the context. So it reduce the context. So now this is my UI I'm having. So I'm having 2 modes. One is a tool loadout mode and baseline mode. Let me initialize the agent first. This is nothing but invoking this method. I will show you in the log the whole thinking process. Let me drag it here so that you can see now we can see that tools are 50 tools are available for it. So agent got initialized. So instead of writing, I'm having some default queries. I'll list it down here. We can pick up one of them. So this is my question. My EC2 instance seems to be running slow. How can I check what's going on? Okay, this is a question somebody is asking. So let me execute this code. And now let's go back and see in the logs. Now you can see it is going to the agent executor chain mode. Now you can see, basically you can see thought process here, right? Thought. The user is experiencing a slow performance EC2 instances. I should first check the current status of the instance to understand its status and resource usage. However, I need the instance ID to proceed. This is a thought. It knows that for this thought, it requires the action. Now action input is this. Now it has picked up the found 30 candidate from the Pinecone, re-rank to top 20 and find 2 high quality tools, okay, using top 10 results. Basically what I'm doing, I'm also doing re-ranking. I'm not just blindly getting the data. I'm re-ranking the tool so that, I get only relevant tools. Now it get only the relevant tools. And now BaseNet is answering the question. Now we can see that the final answer is this. Okay, this sometime issue with this one. Sometimes it doesn't give you the. Okay, maybe let me try one more time. It didn't perform fully. It stopped in between. Let me execute again. No, that's an issue I see with the agents. Each execution gives you a different answer, right? Same answer not guaranteed between executions. Like I can ask the same question twice, I'll get a different answer. So that's very challenging to test. Typically when we are used to testing an application, you write test cases, you plan test cases and everything. You know that, okay, this input gives this output, which is very different here.
Yeah.
You should be able to get the same answer every time. Right?
But again, the tool selection might be different. I think something is going wrong here. It is not. Yeah, it is giving me the answer, but not the what I want. But having said that, but you can see that it selected 10 tools here. Okay.
So before we go further, I just want to talk about the non-deterministic nature. So this all depends on because LLMs, we all know that pretty much everything is non-deterministic. You ask the same question the second time, there's no guarantee that you get the same answer, right? So it would keep changing. So that whatever the inherent properties of an LLM will be carried over. So you'll still have the same problem. But as the LLMs get better, right? If you know about the Thinking Machines company that Mira Murati had started, if you're following OpenAI and the people that are coming out. So they have recently published a paper which is groundbreaking in one way if you use it the right way, without having the LLM start, doing the fine tuning. They've created a methodology to reduce the hallucinations and increase the deterministic nature of it. So if that actually gets propagated for all the LLMs that are out there, which have been already, trained upon, the deterministic nature will be much higher, and your tool generation and all these kinds of things that we base our agents on will become better. So I'm expecting 2 years from now, you'll see a lot of deterministic nature in LLMs being built automatically.
Okay. Let me also try now with the baseline tool. That means the same question now I'll ask, but I'll use all the available tools, not 10 tools. Let's see the execution now. Let's see what is happening now. How many tools it is selecting now? Now it is going thought, the action, it is listing all the EC2 instances. Now it will go to the next thought lifecycle. Now it is observing again. Now it is getting EC2 instance. It is going next thought lifecycle. You can see each thought lifecycle. I can see that DB server production has high disk usage at 73%. It is taking next action. So it has again going to another action. Now it is taking load balancer, health checks, it is doing performing.
So it's running locally on your
Yeah.
laptop, right?
Yeah. Maybe something I should not have done. Just yesterday night, after going home, I tried to tweak this little bit. Maybe I played with a little bit. That's why the baseline tool is not
I think
working.
it was good.
Yeah.
Okay.
Now you can see it is actually, now this is baseline tool. You can see it is giving you the answer. It is doing step 1, step 2, step 3, step 4, step 5. It is giving the final answer. I was expecting same thing for the tool loaded mode also. Something is went wrong. But you can see that it is selected 50 tools now. Okay. It went to 6 iterations. Okay, now I don't want to change the code online, but I think the number of iterations got messed up in other. Let me try again. So let me walk you through what happened here. You can see that first go to the log. That's what the beauty of the React agents. You can see that with the first thought, just you ask one question, it went to this thought. Based on this thought, it took this action. And then it observed the results of that action. And based on this observation, it went to another thought life cycle. Right? You can see that this is observation. I can see that there are several instances running. Since the user mentioned their instance is running slow, I should check the status of the running instance to identify the performance issues. Now for that, it should take another next action. Now it is observing on that action. Now we can see that I can see that web server instance at 85% usage. You can see how it is going in this life cycle till it reaches the final answer. Okay. Now let me also go to Langsmith now here. Okay, Langsmith is a observer tool where you can actually observe everything going on agent. If at all you are working with agent, this is a must tool. I'm not saying Langsmith. You can use Langsmith.
Fine.
Or you can use LangChain. You can use any one of these tools. So now I can create a project here. I can show you both the traces. This is you can see that this is the one which just now executed with all the tools, right? Oh, this is, I think I ran this yesterday. Maybe I can show you both of them yesterday when I ran. Okay, so you can see that when you go open here, it shows you the number of tokens it has used. In fact, there is something wrong. I'm not able to figure out. If you use DeepSeek, it doesn't show you the cost. If you use OpenAI, it will show you the cost, number of tokens, what is the cost also. Now, it shows you all the chain, like how many tools it has used, everything. You can pick up another agent. You can actually compare. Let me try to compare 2 agents, which are I can compare both the runs. Can you see the difference between 34,000 tokens versus 1,400 tokens? In two loaded pattern, I'm able to get the answer with 1,104 tokens. When I'm passing everything, I'm getting 34,000 tokens. The latency, it took 50 seconds here, it took 6 seconds here. That's the difference. Imagine you are having, as I told like in the beginning of this call, at some point, this guy could be your team member in your Slack channel. You can just hook this with a Slack webhook. You can ask a question. Every time you ask a question, it goes to the Slack webhook. The Slack webhook will invoke this agent, gives an answer, puts you back in the Slack channel. So you are asking, your team members are asking the questions. This is running row, no low. I'm having this network issue. This error, it is doing some error. Troubleshoot me this error, like this, all these things. Now, a big company running like thousands of employees. Imagine the amount of money you are saving by reducing the tokens, right? That's the difference between using tool loaded versus non-tool loaded patterns.
Yeah, quick question. So from a cost benefit standpoint, right? Like let's say you deploy something like this in an enterprise. Are there any models that actually tell you what the benefits are in your experience?
No, benefits for what?
I mean, like, okay, so you deployed this agent, right? How do you measure the benefit of the
Okay, how do you measure?
Yeah, I mean, like you're spending a lot of money building this. You're going to spend money on an ongoing basis. You have to pay for the tokens, right? But this agent is always up and running, right? Now that's going to be incur a significant amount of cost. So are there any models that talk to you about the benefits?
Yeah, maybe you're talking about something like ROI models, like where,
ROI,
maybe I guess that could be very specific to every organization. For example, if I'm having only 10 people startup and then I'm having this tool and I'm burning like, a lot of money on API calls, infrastructure, and so might not make really sense there, but versus a big enterprise having some 100,000 employees and they're all using, maybe at some point the cost might this kind of a bell curve, maybe it might optimize something.
The reason is that if you really think about SaaS versus LLM based development, SaaS is actually the more you use, the better off you are because you really want the consumption. But in this case, the more you use, the worse off you are because you're paying a lot more money.
Again, that can be optimized here. For example, we have a lot of something like you don't have to use API model. If you're having something like a SageMaker, you can go and deploy your own model there. Like you can just take a DeepSeek and then deploy. You can use together AI, where you can optimize cost to some extent, or maybe there is a possibility that where you can take a smaller model and fine tune the model for DevOps activities. Right, I can take a
So I understand all. Maybe a question to ask really is before you start building something like this, right? How do you estimate your return on investment?
Yeah, that's.
I mean, is there a model that's
there are based on the return on investment. Yeah, it is possible because right now every LLM company or every companies are publishing their cost per millions of tokens, right? How many millions of tokens you have? If you use these many tokens, this is what your cost would be. So taking that as an example, and based on what he has shown as if you use DeepSeek model versus non-tool loader, pattern versus tool loader, if you load every 50 tools, these many tokens. So you can actually estimate prior.
Understand, right? See, once you build, let's say, a prototype, then it's obviously you can figure it out. But what I'm saying is, like, even before you do that, are there models that you can? I mean, I'm just asking, like, is there a formula, a spreadsheet that says, okay, if I want to build this agent, here is the ROI expected.
That could be a good, good startup process.
I know. I mean, I'm just asking if you guys.
No, I haven't.
In fact,
because
maybe we can build an agent around that.
Yeah, because that could be an agent on its own. Depending on the number of tokens and per cost per token. Per million tokens, you can actually estimate.
No, I mean, I understand. I mean, if you know
there's no tool. I haven't seen.
Yeah. Okay. Any questions on tool loader before we move to other pattern?
I have a question here on the tool loader techniques. we're trying to implement this to give it more context, right? I'm just trying to
Less context.
context. So what I'm trying to achieve from here is
Less but relevant.
yes, relevant. So that's what I mean by giving more in the sense of the other way. But
Yeah.
So let's say I just understood from this demo that if we use tool loadout with more tools, our tokens will be more because we are giving it more context. So our cost will be increasing from that standpoint, and time also. You have seen latency over there. Once we give this tools, the latency is less. So it covered time and money. So I'm trying to read between those lines. Is there, if I use tool loadout, will it give me more accurate results? Because on one of your slides, I saw 44% performance improvements when you use tool loadout technique. So is it also relevant to the accuracy? Because let's say in healthcare, I can consume more. I'm open to consume more cost. I'm quite flexible if I consume more of my capacity. And what I'm looking for is the accuracy. If I use tool load, will I get more accuracy? Is that what
I guess
44% performance?
Maybe if for asking accuracy, right? It should give you more accurate result. But again, we need to measure this, like, how grounded your results are, how accurate, how relevant, faithfulness. We need to do a measurement. I don't have done that type of test. Actually, it's a good thing. Maybe I should do next. Maybe there's also a good option. Like I can do the test running on this. We could have some parameters like what is the faithfulness, what is the groundness of these answers, and how relevant these answers. We can do all this RACs type of testing to carry and then measure the performance. But think like this, right? Imagine it should give you more accurate results now because you are using only the relevant tools. So what if I give all the 50 tools? Maybe in some thought life cycle, agent felt that it has to use a different tool altogether, right? Maybe it might go in a different, it might misguide the model with the wrong information. So this is actually avoiding that. It is trying to keep the context limited only to that. Again, it all depending upon how good your documentation for the API also. If you can properly document, for example, here I wrote very simple. If you talk my tools, okay, I'm having very simple documentation here, which says that create a manual snapshot. What if I just adds more information like the use case for this? Use this method for user asking question like if you want to backup RDS, if you want to before deleting a RDS, you should this method should be called. If you add more context, if you add more information here, more context here, obviously the number of tools you are going to get is also better. That improves your the tool selection pattern. That's why I feel that if you're building a tools, this is a very critical piece of information. Put as much relevant information here so that your agent, whether using tool or not, even if you're using all the tools, put good information here so that model picks up actual tool here.
I get it. So I just want to understand what it meant by performance on that particular search.
Maybe performance is, if you can see the performance, this time has definitely increased compared to latency has improved.
Cost is
drastically reduced.
38K to 1K.
But accuracy, again, we need to measure. I don't have a correct answer.
So that depends on how good the tools are being made. That is what he's trying to get to. If your tool actually has enough information to build the right data to come back, it is much easier. So the accuracy levels depends on how good your tool is or how good your tool actually tells about itself, right?
See, I think from an accuracy perspective, if you don't use any tools at all, you will not get anything back.
Yeah.
That's the problem, right? So if the reason why you want to use tools is because you want to make your how to determine it.
I think it's not whether using tools or not. The tool loadout, if you select 16 or on that one, I've seen selecting 16 or something gives you better result than using all the 50, right? So
sure, see, I think you can also design something which will consume far less than the 1,000 tokens. So that's the challenge.
Yeah, even
as an engineer, that's what you have to figure out.
Yeah, the patterns are getting developed as we see.
I'm just looking from the outcomes points of perspective, not from what goes in and.
Yeah, again, that all depends on.
How do you measure that? How do you compare?
There are some predefined tools. There's a frameworks are there, RACs is there, some tools are there, which you can actually using the tools, you can, in fact, that is available here also. If you can go to Langsmith also, there are some monitoring is there. In fact, I did some time back. I don't have it right now ready, but you have something like, error rate in LLM calls. There is some, you have some APIs like RAX framework is there. You can using which you can measure the relevanceness, how grounded this answer is there. There are some metrics like relevance recall and everything. So maybe we have a separate session for that, but there are frameworks available.
Yeah, as we say, right, these are all evolving, so there's no definitive answer.
Yeah.
Come back and say like, hey, use this tool, this is the best one. Because every time these kind of questions, if you're to have, if you're all working in a group, let's say like we're all a startup, we're all working, each one of our question will become a feature for our product that, to bring in. So, that is how it becomes.
Okay, I'll quickly, I know I'm running out of time, so I'll quickly go to 2 more demos, and then I'll focus more on the demo than the code now because by the less time I'm having. The next one is context offloading. Okay, this is what the example I told you. Like the analogy is that the one thing I told you, maybe I'll repeat it again one more time. Like if you're attending a day-long conference, okay, with 10 different sessions, you don't want to and someone asks you to summarize your conference end of the day, you will be overwhelmed with information. What if at every session you write the information what you got, summarizes it in a notepad, maybe put in a memory? Obviously, end of the day, someone asks a question, you are going to give very irrelevant answer to them. That's what context offloading is all about. So the way it works is you have the user, whenever user asks a question, you are going to put some of the context into 2 different ways you can put. One is called Scratchpad. As I told example, like you are doing some web search, and once that web search is done, you write that information to Scratchpad, because the next action of the agent, which is to retrieve some data from an internal database, doesn't require this information. So you don't have to put that information in the context. You write in a Scratchpad. Now there is another action down the line which requires this information in Scratchpad. At the time you retrieve this information. Okay, that's called Scratchpad. Other one is the memory. It happens, for example, that's what, if you go to ChatGPT today, you can ask it a question, even it knows that what you have been talking to from last 6 months or 1 year, right? It is an interesting thing I did some time back. I think someone shared me a prompt, which if you give the prompt, it tells you what type of person you are. Because it is, even if today you can go to ChatGPT, if I've been using, based on my conversation of the last 6 months, tell me what type of person I am. It tells you, it gives you proper information. You are interested in this, you are interested in this, you are interested in this, this is your hobbies, like that. It tells you that. It is using a memory behind the scenes. It is building a knowledge graph about you. I'm sure in couple of months or year down the line, ChatGPT is the one knows you more better about you than anyone else.
Yeah.
Because people are using it left and right. They are using, maybe it knows better than your wife.
Yeah. Actually, no, that is true actually, because they can do better agents, like personalized agents for people, because they're giving everything. They are using that with a personified approach, where they think like, they call it names. They give some names, and also they can say like, they're giving all the personal information. Like, I have this problem with, they don't tell even to the doctor sometimes, but they're sharing with ChatGPT. So it's pretty crazy how people are, giving out that info.
In fact, yeah, that's
Giving personalized information.
Yeah.
In your scenario.
In your scenario, because you have done this earlier. That's exactly what they're building. The whole context about you is being built. That is scary.
Yeah, that's what I told. There are 2 type of method. One is called Scratchpad. One is called persistent memory. In Scratchpad, we discussed nothing, very simple, very intuitive. It could be some text file, it could be some database where you just write the information which you're having. And in case of persistent memory, there are 3 types of memories there: episodic memory, semantic memory, a procedural memory. We'll quickly touch base what all these things are there, and we'll see them in action in the Zep memory. So episodic memory is something like you ask, what is the Dallas weather yesterday? Okay. And then you would said that, Monday I had some oatmeal for the breakfast, and you said that Wednesday I'm having this. It is keeping a log of everything. Every time you're talking to it, it is keeping a log like this. Okay, type is meal log, this user ID timestamp. That means today morning you ate this, 2 days back you went to New York, 10 days back you had some stomach upset, you went to doctor. 15 days back you asked me about a symptom. You are worried about some symptom. You ask me like, hey, what is the symptom is all about? It knows like what, then it is actually connecting all these things. It is building that episodic memory of you. That is what episodic memory is all about. Second is the semantic memory. Okay, where it stores about not tied to a particular user. Okay, so I'll show an example. I can see an example like one of the health agent I built. If I ask you, is mangoes is good for diabetes? All right, you ask generic question, but that information not related to the user. It is very generic information. It is building that semantic memory. It knows that, okay, mangoes, sweets, diabetes, and then this could be somewhere related to this user also. That's called a semantic memory. This is a knowledge which doesn't have much context about the user you're talking to the use case, but it is about a generic knowledge. Second thing is that the procedural memory. That means you are asking the agent to perform multiple things. Okay, it keeps a track of what is my, I'm asking to, searching for a flight or presenting some options, confirming some booking. This is called a procedural memory, which is keeping in memory. Now, when the user asks the question, depending upon the question being asked, you might present some of the, it could use a procedural memory, it could use a semantic memory, it could use, the memory about the past conversations to the user. Again, that's also depending upon the, you need to get the relevant chunks from that. And that's where we have the tools like Zep memory. You ask question, it can bring you the relevant context from MIT's memory, depending upon the question you're asking. Okay, so to summarize, right? So episodic memory is all about your past user experiences. Typical tools we use like Zep or LangGraph or Knowledge Graph. Something example prompt is like, where did I book last week? Then it will, how it's stored as a chat history or notes in a knowledge graph. I'll show you that after this demo. I'll show you quickly that one. A semantic memory is about general facts. Okay, as I told, what is the capacity of Italy? Procedural memory is about skills instructions, which is used in a Scratchpad or Redis or Jep notes. How to book a hotel. It keeps track of, like me. You ask for booking a hotel. It went through all the steps at the first. We'll search using this, hotel API and to, do this task, this task. The whole procedure is stored in a memory. So next time you ask a question, it knows like what is the path it has to follow. It doesn't have to redo the reasoning, everything again. Okay, let me quickly show you the Zep memory. I should have. Okay, I'm using a demo project here. This is coming from the Zep memory. Zep is basically a tool which you can use to store all the knowledge graph about the user conversation. And you can use this tool to retrieve that knowledge whenever user asks for a question. So in fact, you can see a graph here. Every time you are asking the question, okay, it can show the episodes. Like this is what it is actually keeping track of all the questions user is asking. So Hotel Paris Central located near, and then this is a user John Dio is assisting travel assistant bot. He's planning trip to Paris. It is all depending upon all the past conversation user is having. It is building this knowledge graph, right? So what we are going to do next is we are going to build a nutrition agent. This agent, it can do three things. One is that it can keep logging the information. Like every time, like today morning I had this breakfast. Today's this is my weight is this much. My sugar readings are this much. And then you can say, I ate this for my lunch. Now it can ask a question. what should I suggest me something for my dinner, depending. Then it knows that what you ate for breakfast, what you ate for lunch, what is your weight, what is your today, how was your your sugar readings, how is your BP today. It knows reading. It will build your meal plan for the dinner. And then you were saying at some point, hey, I ate pizza yesterday, I had a bloating. And after a few days, you come back and ask, I'm planning to have pizza for dinner. It tells you, hey, your weight is this much, your readings are this much in this day, and you had bloating, you had episode of bloating, stomach bloating when you ate pizza. So I don't suggest that, right? Of course, the agent I built is no more near to perfection. It's still in a development stage, but at least I can show you how you can actually build this. First, let me walk you through the code, and then I will show you the demo in action. Okay, or first I'll show you the agent, and then I'll show you the code behind that.
Yeah, I think that is better. Maybe the sample would be actually.
Then you'll be able to connect better.
Yeah,
part.
correct.
Yeah. Okay, so this is my agent. Okay, so I'm having a lot of actions. I'm using, you can type anything here, but just to save some time, I divide this into 4 sections: morning routine, midday activities, evening and dinner, nutrition questions, analysis. Here I can log something like this. Okay, my weight is 70 kgs. So it goes and logs into the Zep memory. I can show you this. So I can go this, my project is NutriAgent project. Let me see.
Is it coming up with the graph yesterday?
Should I be had a problem?
Yeah.
No, I think it is taking some time. Still, it is not refreshed. It takes a few seconds to, show the agent. Some problem. I think I'm not sure this could be shown with my free account.
Yeah, but it actually has the thread there.
Yeah, thread is there. Like what I discussed today is October 11. See, now we can see what I discussed just now. It is logging here. Okay. In fact, it is supposed to build a knowledge graph. One thing earlier, I'm using a free account. I think there is some restrictions on something is there. So I'm running out of my credit, looks like. Now I go here. Maybe I'll add some my sugar today. Okay, now you can come and see here. After some time, it takes few seconds to refresh knowledge here. Yeah, but it's coming here quickly fast. It's coming here. Now I can go and ask it some questions, or maybe I can put my, what is my breakfast today? Because you need to give some data to it. And again, whatever the data response you see is not just based on what I'm seeing today, because I've been using this for some September 20th onwards. So it is having a lot of data. Of course, it might be some conflict information also. See,
Sorry, I have a question here. How should I look at Zep? Is it an app or is it another agent?
This is a Zep is a tool to store the agent memory. It is agent memory.
So you're plugging this to the agent, what you have built on Azure. Okay.
Yeah, this is a cloud base I'm using. It gives an API key. You can use that API key, you can build this.
Have you taken any subscription for Zep?
Yeah, I'm using a free tier actually. It looks like in free tier it restricted number of API calls something, so that's why I'm having this problem. Now I will ask some nutrition questions. Okay, so what is the best source of protein for vegetarians? Let me ask this question. Okay, now if you go here, what is happening is I'm using a Perplexity AI to gather the research. Okay, it is asking, what I'm doing is I'm rewriting the question. Sometimes user might ask a question which is not really in a good shape. So I'm using again LLM to rephrase the user question and then ask the question. For example, the question asked has become something like this. Searching for this one. It is going to Perplexity API and getting information. Once it gets, it's still processing information. Now generating personalized response. Okay, combining research plus your personal history. Is doing both of them. Okay, it is taking time. I'm using One thing I noticed different between using DeepSeek versus OpenAI. If you use DeepSeek, it's very low cost, dead cheap, but it takes some time to get the response back. OpenAI is really faster. Yeah. Now it has given me the, this one gave me all these things. It is giving me personalized breakfast plan. Okay. Next, I would add some midday activities. Okay, maybe I'll ask my evening dinner. So let me ask, what should I eat for my dinner? Of course, now this is not using the context what I told just now. It is using all my previous data also. So the response you see might not be like really aligned to what I just spoke to it, because you can see here it is having the memory from so many days.
So Krishna asked a question earlier about this knowledge becomes history. Yeah, that is exactly what.
Yeah, this is exactly, yeah.
Been shown.
Now you can see what is happening. It is actually getting the research data. It is getting user memory. It is combining research plus personal history. It's combining both of them. And let's see what is dinner suggestions, storing nutrition. It is again, what are you suggesting? Storing insights again.
But why we need a separate memory for this?
Because you don't want to overwhelm the agent with a lot of context. Like if you store all these things in the agent context, it's like agent context like agent memory RAM. Context like a RAM of the user. You don't want to put all the information to the RAM. You want to only put only relevant information. So if I'm talking to it from last 25 days, I don't want to put all the data into this one. Or I can, for example, I can log out, I can come back after a few days also. If I ask a question, that's why if you see here, your personalized, strategy for nutrition dinner, it is giving me all these things.
Now, if you see the tools now, for example, Databricks, Gen8, so where there is the inference table concept, whatever you ask, it is stored there in the table. Now you give the information and you use LLM augment and give the response. Now, this is where again it's a different way of
yeah, but the what you told for getting the augment the context, right? There are different tools to give info. Okay, to give different to give context to the agent, there are different tools. One tool could be, as I told, could be a database, a RAG. Other could be a memory tool. Okay, which will build that knowledge graph and then give the relevant information to the user. It's all about how relevant information you can give to the user.
Yeah, LLM and RAG, what you mentioned is more about a generalized context. It is like, it learns everything, but it's not actually specialized in specific topic, doing specific things. Agents are like, that's how we hire people also, right? They are meant to do, they're like very specific skill set is there for them. They'll do that stuff really good. That is why we hire them. And those kind of skills are actually, about different people. So we cannot have generalized context doing everything. I mean, generalized LLM can do, but it may not actually specially do the things that you really want. That's the difference.
See, actually, you can see here what I'm highlighting sentence, because since I'm using it multiple times, I told it that I had oatmeal and fruits for my breakfast. It is actually saying this, of course, based on consistent habit of building balanced breakfast, oatmeal and fruit and protein. It is suggesting this. It knows that I have used multiple times when I was starting testing this app. I had a oatmeal for breakfast. Right? It is remembering that and bringing that information now. Now, if I ask it any correlation with my meals and blood sugar, if I ask this question, let's see what response we get. Now, again, if you see the backend, it is not using research, not using, it is only purely using memory. Based on in memory, whatever data is stored, it is getting that data. Let's see what response we get now.
The question would be, you're giving additional selective context based on what you have put to the model. But then based on the question, is there some selection criteria, like you've given it your morning routine and you've given your dietary and stuff and a lot of other information? How does it know that I should only use a certain information? So for example, maybe the morning routine may not be relevant when I'm doing the dinner plans. So that whole data of morning and afternoon, I should just discard it. Not
that's where Zep memory, when you're getting relevant information, that's where the knowledge graph is building. Depending upon the question, it knows that I need to get only the information related to morning routine, right? When you're asking for a what are my breakfast options, it knows that for breakfast, it should know what you ate in the morning, what you ate in the afternoon. And it should know like, how was your weight today morning? How was your readings today morning? Based on that information, it is building that information. That means when it goes, it is getting the information and is taking ZEP memory. It is getting the thread. If you see, it is getting the today's data.
Yeah, so let me add maybe some more variations to that. So in this set memory, I have my dietary plans and I also have my say travel details. Right? I travel, I've been here and there. But when I'm asking the question about my dinner plans, the travel may not be relevant. It's not relevant for what my diet should be. Maybe when it's suggesting a restaurant, the location might be relevant.
Yeah.
Where I travel as well.
That is where the
How
knowledge.
is it selectively?
That's again, we are taking help of ZEP for that.
So it does it.
Yeah, it does.
Basically, it all depends on the knowledge graph. Basically, that is creating the knowledge graph. Knowledge graphs are so important to see what is more relevant for that particular time. If it's dinner, it has like it all actually gets converted into matrix values anyway, right? So what is the nearest value that I can find? He's saying this is the next one. He's talking about dinner, but he has been traveling. He's in a different location. So the knowledge graph actually gives us weights to actually be considering those because you have been traveling. That is also given a little bit higher weight that actually connects with that. That whole knowledge graph is the basis for giving you the better answer. If you are just doing the prediction values, just like LLM, what comes next, the next word, you may not be as good as the knowledge graph. That is the knowledge graphs are important. That is the ZEP memory has built that mechanism to create the knowledge graph based on what you're asking in the context. A lot of people, I mean, not a lot, but many people are using ZEP for that knowledge graph aspect.
So this is similar to RAG, right? I mean,
this is similar to
Yeah.
RAG, but RAG actually has to, every single time we have to train the data. It is similar, but
I mean, it's.
the RAG actually does only the vectorized databases with some, nearest
I understand, but I mean, you could think of this as a
similar to that.
knowledge RAG, right?
Similar to that, yes.
Okay, I have some questions in the chat. I think Priya, she raised a hand. Is Langsmith same as Google Stacks? Yeah, okay, you answered this question. Okay, yeah. We can move on now. Again, we can anyone, this is open source. You can actually, the code is there. I can walk through the code. Anyone can take this
they
code
want the
and
GitHub. If you can
find
share.
it. Yeah, I'm going to share that now. I'm going to share end of this.
End of the session you can share.
Okay, now let's quickly see I want to quickly walk you through the code of this. Now, basically, it will answer a lot of questions like how you are getting from the ZEP memory and everything. Okay. Now you can see that the first we are using LangChain, DeepSeek API, generalize this one. We are using ZEP, which is you need to get a ZEP API key and then use that one. Of course, all of them are some .env variable. This is only for, it won't use this one. And for all the Scratchpad, I'm using a state object where I'm having Scratchpad string user message. This is like your temporary. When you shut down this model, this Scratchpad is gone, right? So this is used as your, when only during that session, user session. If you know the concept of user session, you will use that during that session. So whenever user is doing, an agent is doing multiple thought action life cycles, the data which is there in one action, which might not be relevant to next action, it is threading Scratchpad. That's it. It is pulling that information from Scratchpad. This is also called DeepSeek, and then this is called Perplexity search. Whenever you ask a question which is not generic, it will ask a Perplexity search. Right now, it is getting daily thread. This is, as I told, if you want to know what is I have done today, I'm getting daily thread will give me my conversation for today. That way, I'm asking plan my dinner tonight. It will get the daily thread today, and then based on that what I have eaten today, it will plan accordingly. This is some simple method to classify my data into, depending upon the word. It is not near perfect, but just for a demo sake, I just did a quick classification. And then this is something like to make sure the user exists. I'm having a free account, so I'm having only one user. And then this is make sure the thread we are asking exists. There is no thread today, it won't get the data. There is no thread available because I haven't talked to the agent till now. Okay. This is in a line graph, we are having this node-based structure, right? Where first node is to analyze user intent. When I'm asking the question, I want to know what is the intent of the user, whether user want to log the food, he's asking some general question, or is he asking something else. So I'm planning to analyze user intent using this particular node. Okay, here again, I'm using LLM. I'm asking it to classify into health log, nutrition lookup, recall, compare, chat, like 4 different categories. I'm giving some few short examples. The question is this is output has to be. Based on this, it will analyze, it will classify my question into multiple intents. Now, I'm having query rewrite. Sometimes user will ask a question, but if I want to do a reset perplexity, I want to properly rephrase it so that I'll get a better information. I simply ask, is there a protein in this food? Instead of that, maybe I can ask, maybe I can make it very broad-based question. That's where the rewrite is happening. So here I'm taking the prompt, it is taking the user question and then rewriting this particular user query. And using perplexity search, it is hitting perplexity for the searching. You can see that every time I go to perplexity, hits perplexity, I'm storing in the scratchpad. So all the research I do when user asks a question, it is there in the scratchpad. This is my Zep memory store node. Every time I ask a question, I'm extracting the intent, topic, user message is getting stored in the perplexity. Okay. So if intent is me log, I build this message and then store in the Zep memory. If intent is this, I'll store in Zep memory. Okay, this is one node to store everything. This is a LangGraph node because LangGraph has got nodes and edges. So this is another nodes. I'll show you how the edges are there. And then this is a retriever node. That's where we are using Zep memory. We are based on the intent, based on the topic. We're getting get daily threads. And then we are using get user context. See, this is what Zep memory is giving you the context based on the user, for that thread. For that thread ID, getting user context. And then we are using the memory content in that content. We're trying to fill when you get the memory in the Zep, it gives you the facts and entities. So all the data you were storing, like, I had a breakfast today, I had this much, my weight is this much, my sugar reading is this much. There are some facts, there are some entities, right? My breakfast is this. That means user had a breakfast. The entity could be something like he had a breakfast of oatmeal. All these things are stored here. And then it is getting all the, when you, in fact, a Zep memory, it gives you what is the facts, what are the entities in that data which is being stored. Then this is one node to extract nutrition insights. And then this is summarizing everything. Okay. To summarize, it is getting from the scratchpad. It is getting memory content. It is getting the user message, getting the intent. It is doing the, depending upon the intent, it is doing the, I'm having different prompts. Okay. So, and in the end, we are creating this LangGraph node. So a start intent, and these are all the nodes. The entry point is this one. And then these are all the nodes I told you just now. And this is my entry point node. And we're having conditional edge. If the intent analyzer, route by intent, it is going to these nodes depending upon this one. Sometimes I might say, hey, what was my sugar readings today? It doesn't have to do any thinking. You just need to go to Zep and get the readings today. These are all the edges. You are connecting the query rewriter to perplexity search. Then this search is going to memory retriever. Memory retriever is going to LLM summarizer. These are all the edges in the LangGraph. And then route after summarizer is this. Is a conditional. Of course, these are all LangGraph. Then you compile. In fact, I didn't write the code here. If you are using in a Jupyter notebook, you can ask it to print the graph. It print the entire graph for you.
And also the code that you have written on this, right? You used, did you handwrite this code?
No, Claude.
Exactly. So that's
the days are gone.
That's the best part. Right? So the main thing that we have to take away from all this is you don't have to write this code, but you need to know the conceptual idea.
Okay.
Right?
Yeah, I agree. The way I do is, as I told, I usually talk to Claude. I think Claude is like my junior developer. I need to talk to it. So before I'm building this agent, I will go to Claude and say, I want to build the agent. I want to have these 5 LangGraph nodes. This node has to connect to this node. This node has to this connect node. You have to use Perplexity API for search. You have to store in the zip memory. Now, after giving all the information, first question I'll ask is, can you summarize what I told you just now? It will summarize everything. Then you can figure out some mistakes it has done. Can you correct these things? Then you can talk to it for like 5-6 rounds. In the end, you ask it, can you summarize all the solution approach you told it till now? It summarized. Now you say, go ahead and generate the code. It works flawlessly if you do that one. So I ask anyone to using Claude, please talk to it. More you talk to it, more you understand. It understands better.
Gandhi, I have a question here. Like, now that you have used Claude to write the code, and then you're calling Perplexity through an API. So my question is like, and then we are comparing ChatGPT, OpenAI ChatGPT, and then DeepSeek, right? Number of tokens and how it's going to cost us per call when we are using those models as in the back end to do all the work. So how is it in the market? Like, if I come from a sales perspective, so all the business development teams and all those teams, if they have to go to the client and see, building has become very easy now that you are sharing. We are seeing it; it's a live demo. So we have access to all these tools, and with your knowledge, what you're sharing right now, so we can sit and build something. But if we have to go back to the client and convince them, is this, all the employers started doing this? Have they made this part of their, sales packages? We're going to sell differently. That is definitely going to be the future. We're not going to sell like earlier, what we were doing, all the sales teams, or, including, see, the reason why I'm saying is like in my work, with my previous employer, I worked with sales managers and client relationship partners and client relationship managers. So one basic challenge that I constantly hear from them is the competition, and then trying to convince the client to modernize their applications. Given that we are in the wave of AI, it's going to be even more complicated.
So you're asking like, how do we convince the customer on the value this agent brings up?
What's the market is looking like? Like, have we already including this as part of sales presentations? Request for proposals, sales demos that we give.
Yeah, I'm not sure about how the sales, because I'm not in the sales domain for now. Currently in the current role. Again, what are the knowledge I'm having? What are the information I have? In terms of value, right? Again, one of the first thing, if you want to convince a customer on the value of AA agents, agent building, first, you have to take stock check of what is the problem you're trying to solve. You need to be very clear on the problem you're trying to solve. Okay, like whether are you building agent because the technology is cool? No. Is it really solving the problem? There are a lot of times you are trying to build a agent for which it can be as simple an app could be enough. So then you don't have to require an agent. An agent is required where it involves some amount of reasoning, decision making is required, and you have to make an intelligent decision making. Maybe that is a right use case. So first of all, figure out, like, if you want, even before going to customers, convince customer, figure out whether the use case you're trying to tackle is actually require an agent for that or not. Right?
Yeah, that's an ideal way, but what I think, I have a different approach to that one, right? For example, if you're trying to sell it to the customers, and what would the customer do? They want like less amount of money, big bang for the buck, right? They always want to save more. So if you were to show this DevOps agent as an example and say, like, you don't have to hire 10 different people, paying them 100K each or 150K each, 600K, like, for four people or over a year, you take this token cost and say like, oh, you know what, use DeepSeek, cut down the amount of time. It might take a little while for a few seconds, but you might have like 4 different people's work getting done by one agent. That would cost you, I mean, if the customer can see the value of actually saving the money, he would jump in right away. That is how people are hyping it up. Frankly speaking, in the current AI world, everybody is like, I'm going to save you like tons of money, but they're not actually talking about the details. What he has presented is very important because a lot of people are not looking at the FinOps aspect, the token amounts that we would be selling. It's more like, having the cloud versus on-prem. Everybody said cloud is like the best option to go, they are going, but that's more for startups and other things. You can quickly churn up like all these instances. But when you have the ingress data, they are fine. But when you want to take your data out, if you're a regulatory company, taking the data out from Google, nobody has done it actually, and it will cost a lot more than actually putting the data in. So this tokenization aspects and other things, I think Padma, right, asked the question.
Yeah, Priya.
Those are the important things that people are not actually doing a deep dive. They're going more wider from a sales aspect. And if you're selling it, it's easy to sell to replace people. Everybody, that is why we are creating the hype of replacing the people. Yes, it is possible, but without, I mean, it's not like everybody will get replaced. Some of us will, if you're not actually connecting yourself to these, latest techs and how we can actually utilize them for ourselves. So there's a lot of hype. You can sell for now for any time. I don't think you'll have a challenge down the line, in my opinion.
So a couple of points, companies are trying to sell agents. So I work for software companies. They're having a very hard time convincing their customers to buy. I think the challenge is how does it fit into an existing system landscape is always going to be a problem. So unless you are a vendor selling software, so I used to work for supply chain software company. So my ex company, they are now trying to build agents and trying to sell them. I'm in touch with these guys, and they're having a hard time because customers say, okay, what is the value? How is it going to fit into my landscape?
Actually, I'm thinking there are two ways to look in problem. There are two different type of companies agents. Okay, you take any startup now. Okay, they will be agent from day one. Agent. So for them, the adoption, building, selling is going to be easier. Okay, but if you take a big enterprise which is having some lot of applications, lot of from so many years, for them actually for them there could be some challenges in convincing their stakeholders what is the value addition this agent is going to bring, and even to change their existing whole the customer current product into agentic mode is a challenge. So there will be two different ways people look into. You have an agentic company or non-agentic company going forward in the future. An agentic company is one which can adapt quickly to this, or maybe typically all the startups, small mid-sized companies, easy for them to adopt.
Yeah, no, I completely agree. I think I was talking more about enterprise content.
Yeah.
Right? I mean, I think that's the question that you probably asked.
Yeah, that's where the tool building, right?
She worked for some TCS or Infosys or something.
Yeah, I don't know, but the tool building capabilities, right, that he has shown, right? Those are the most important parts for an enterprise to actually expand of agentic capability, right?
Definitely.
The more
about
exactly.
I think I'm still not very clear on it. It's nothing to do with the presentation, but overall, like how does this fit into an enterprise ecosystem? It's going to be a big challenge because a lot of big enterprises have invested millions of dollars in moving to cloud and everything else. Now you're saying, okay, now let's bring in LLM. Like, where does it fit in? How do you figure that out?
I think, yeah, I mean, we can have a long discussion on that because that all depends on what are they trying to solve for, right? That's a philosophy. We go on a different tangent altogether.
I find the best use case. How does it fit in?
I
think it's going to be a challenge, right? I mean,
there are we can see so many use cases. It's the investment. For example, AT&T. Previously, they don't have that kind of history. I am just asking I want my January 2025 date. So it's understanding, it's all building the models, right? Now it's generating report and it's giving. For example, you can go in an agriculture industry where it's capturing the images and image classification. So the thing is, there are so many opportunities are there, all we have to go and convince them. Some are really we can, for example, I work in a healthcare facilities, right? So any customer now I can directly charge like an home bill. So these are all applications of LLMs.
I guess
In there, but
I think as to add to what Vijay was saying, right? The future is going to be maybe I'm not taking much time. I'll give a quick example.
We
Okay?
are like 5 minutes here, but I don't know if people can stay back.
If you can stay,
Yeah, a few more minutes after this, actually. Yeah. I think this is a good discussion we'll continue to have because, you know, to your point, enterprises are still trying to figure out and some have already figured. I cannot give examples of what we do from my employer side, but we are going fast, right? And there are other companies who are actually utilizing real good context engineering, not from an engineering perspective, but they are utilizing Copilot. For example, Windows, right? I mean, Microsoft. You haven't seen how much progress they are actually making inroads in enterprise. They are like getting all the documentation that they have from PowerPoint. What people use, Outlook, PowerPoint, Excel sheets. Their data is right there. Once you put in Copilot, it's actually vectorizing everything, and people are utilizing those.
KPMG has Kim Chat, their
Yeah.
own agent inside. No, I'm not disputing that at all. Don't get me wrong.
No, it's not disputed.
no, actually, the future is also going to be the companies who can actually figure out like what I can do with this LLM for my business. If you're able to figure out that, you are actually in the market.
So basically,
Okay.
Oracle as the example had the Oracle AI World. What they are trying to sell is they are trying to, use agents for the existing processes. So in supply chain management, in financials, they are putting in small agents that they're trying to sell.
So that is from the perspective of the vendor, right? Like you have Oracle application. So yeah, you can go and say, okay, now I've got you the next release, and I'm going to give you agents with it. Sure, that's they have to do it, otherwise they'll die, right? But what I'm saying is that
service-based companies, you need to build either domain-specific or generalized agents where you can sell to multiple enterprises. Right? That's how it is. Otherwise, you need to get into their problem and solve using agents.
See, exactly. Service companies will have a problem because they don't have a product.
they have to become product companies.
Exactly. That is the problem.
So they may not, for example, have
The domain problem.
They have
when they
That's a very good point,
When
actually.
they're doing it, Infosys, they have to transform. I call
whatever Gandhi said, right? Yeah, future is going to be agents because there are so many problems that you can solve differently. The problem is same, but you are going to solution it to different equipment.
Yeah, your go-to-market is completely going to be transformed. I mean, you will have to become a product company also.
I think no. One more thing is two things, right? Even the problems we thought sometime back which cannot be solved, now we can solve it. So you need to figure out like what challenges I had where in my enterprise I was not solving all this because I thought I couldn't do. Now I can do it. Number one. Number two is you need to figure out the right use case for your enterprise. These things there's no option for you like going forward. Only the enterprise which figures out like what I can do this technology will survive.
Yeah, Deloitte has already done that. I mean, they are building like wizards and other things that are.
Yeah, I think we'll take a.
APM is doing that. Yeah.
Yeah, I think we'll take a quickly. We'll cover this one and then we can take a break.
Come back to context.
Yeah.
Yeah.
I think
they
this-
build a Kim Chat and they want some award.
Yeah.
This is exactly what is context distraction is.
Yeah, content distraction. So we are having content distraction now. I know we have only 5 more minutes time. I'll quickly walk you through. I know we have like a couple of more minutes. So I'll quickly walk through one more strategy called.
There are a couple of questions online, so
Okay, we'll take an end.
Yeah.
We'll have context pruning and context summarization. So basically what is context pruning is you taking the big context and then removing the unnecessary parts, okay? So that you have only relevant information. And context summarization is, I think they're self-explanatory, not no need to tell anything. Summarization means you take all the thing and then you summarize it. Now the big question you ask is, hey, you are using again LLM to do this pruning and summarization, right? So how it is going to impact now? It is going to impact my latency. It is going to impact my performance. It is going to impact my cost. So there are a couple of strategies are there. You can use an LLM as an API mode, which is going to be expensive. Or you can build a separate model. You can take a Llama 7 billion parameter model, open source model, fine tune the model only for this purpose. That way you are having very lightweight model, which is its only job is give a big context, it will prune it to small. It will summarize the context. That's it. You are having very, and there is a specialized models or something like a provinces that if actually Google province, it is in Hugging Face. The only job of province is to actually take a model, cut it down to the very specific, which is relevant to the user question. Okay. So what I will do is, of course, this is again comparison whether you're using number of tokens versus, it is not always cheaper. So you need to figure out a way to do it cheaper. Maybe you could have multiple ways. You could have a one big model which is answering the questions, one smaller model answering the pruning and summarization. So to do this, what I did is I built again. I'll quickly show you the demo of that. What name on this? So we'll have another agent. So what we are doing here is I took around 5 big PDF files of IRS, okay, and then I stored them in the Pinecone database, okay. Here I'm having IRS documents. Now we are going to ask some questions based on the IRS document. So we are trying to see the comparison. I don't prune the model, I don't prune the context, and then I prune the context. And then if you want to compare, how do I compare? I cannot simply look at the text and say which is good. So what I did is I have used LLM as a judge. So step 1, I store all the documents into the vector database. Step 2, I build 2 agents. One agent will simply retrieve the values and then pass it on to the LLM as a context. In second option, I take the agent, I use a smaller model to prune, and I'm using from Grok a Llama 7 billion model to prune and summarize the context and pass it to agent. Now I get the response from both of them. Then I give both the response to DeepSeek and ask it to tell me which is the giving you good answer. LLM as a judge. Now I'm evaluating this answer on different parameters like a faithfulness, correctness, groundness, relevancy, like this few parameters I'm using to DeepSeek and ask and evaluate. The reason is I'm not using same model to the evaluations, same model to the summarization. I'm having 3 different models. OpenAI to answer the question, Llama 7 billion parameters model on the Grok to actually prune and summarize the context, and DeepSeek for the comparing the responses. So we'll see that now in action. So we are having this model. So I'll ask, I'm having already some questions. So we'll ask, can medical expenses are tax deductible? Okay. I'll ask this question. I'll get an answer. Let's see the log, what is happening here. I'll show the model. So retrieving the relevant, running a plain RAG with OpenAI. Plain RAG means without any summary. And then you're running, after that you're running Llama 3.7 for pruning and generating answers to OpenAI. Now I'm running LLM as a judge for evaluation. Okay. I'm giving both the answers to DeepSeek and asking it to compare which is better. Now you can see that it has, this is a question I'm getting. Okay. Now this is the original retrieved context. You can see that I'm having a big 4,000 characters for that question asked. Now LLM pruned context. Now you can see that I have pruned and summarized the context. I took this big chunk of document. I'm actually properly summarizing this document. Now you can see that my context has come down from 4,000 characters to 62% reduction in the number of characters. Now this is a plain RAG answer. This is LLM pruning answer. Both of them are more or less same, but there is when you see LLM judge evaluation is comparing both answers. So let's see a summary which is winning. Okay. Some cases it is missing. Maybe you can see that. Maybe I can run the same example. Second time it gives a better response. Let's compare the metrics. 9.9 by 10 and 10 by 10. All it is rating. only in completeness, the summarized RAG lost a little bit of information. That means what is happening is maybe sometimes when you're actually summarizing the RAG, it lost some information. That's what it's saying. But let's also compare how is my tokens I'm looking. So I'm going to Langsmith. So this is again a plain RAG, I guess. This is the different. Let's compare these runs. You can see the difference here, the cost, because I'm using OpenAI, Langsmith shows the cost also. This means number of tokens, latency and everything is improved because I'm summarizing the answers. If you can see the context, you can see, imagine someone is giving you this information and asking you to answer a question. Same thing, right? If you give same thing to ChatGPT, ask it a question versus I'm giving this to ChatGPT and asking the question. There's a huge difference because here the information is properly curated, properly summarized. You're giving right information. Again, same example I told you in the beginning. Like you're having a meeting, minutes of your meeting, you're having next meeting, right? You only summarize only the information for that next meeting. You will be able to better prepare for that meeting. So that's the difference between a plain RAG and LLM as a judge. I'll quickly show you. This is a kind of a simple RAG, nothing fancy here. So you can see that I'm getting these PDF files, loading them into the Pinecone. This is what you see here. All the data is loaded here. Okay, different chunks. And I'm retrieving this from the vector store, retrieving the context. I'm doing the retrieval analysis, how many chunks got retrieved and everything, some diagnosis I'm doing here. Again, Claude generated this code, not me. I only ask you to do this one. So I ask Claude, I need a method diagnosis, do a diagnosis on the chunks retrieved so that when I'm debugging, I know that how many chunks it got retrieved and everything. Okay. Now there's a question I'm asking the DeepSeek to evaluate on these. It is giving a score of this one. Again, sometimes, but I'm seeing, right, we should not see the context not only in terms of the response you're getting, but a lot of other parameters like cost, and then if we are seeing only 4 or 5 documents, but if you're having like, thousands of documents, petabytes of data, then it makes a huge difference there also.
Yeah.
Okay, I think I can take some questions now.
There's a couple of them actually. I just want to wrap it up. We are 7 minutes over, almost 8 minutes over. If you have any questions from here? Okay. So Satish was asking, in the context of explainable AI, can we combine the end-to-end process, thought process from LLM and API calls from the code into Langsmith?
Sorry for the question.
In the context of explainable AI, can we combine the end-to-end process, thought process from LLM and API calls from the code into Langsmith?
Yes, I guess thought, that is what thought process can we have in the Langsmith. In fact, we can see, I guess that's what the Langsmith traces is all about. You can go to
trace is there, right? It's actually showing the
trace is actually showing. If you can see the, now let me pick a right example. We'll pick up other projects like this one. You can see the intent analyzer. You can see all the input. You can see the route by intent, ZEP retriever, LLM summarizer. Yeah, you can see that. You can see the entire model tracing.
It's more like observability, right? So
observability.
Langsmith is meant to, it's a tool like Google Stacks. Somebody was asking about Google Stacks. Both does the same, but I mean they have different feature sets. So it is possible, Satish. I think if you're still around. Frank has this question. Zep Memory looks like a great solution to this problem. Has anyone deployed this solution in production? Where is the data stored? Are there any privacy concerns? And how we're all convincing legal to feel comfortable with such a solution? Good question.
Another question.
Good question, Frank, if you're still around. Yeah, so do you know anywhere Zep being utilized in production?
Not We are using it, but sorry,
No, okay. Yeah, I think there are some enterprises being utilized. I mean, we can give out all the information that because we both work for two different employers, and this is a personal session we're conducting, so we cannot just tell all the
You
information.
can disclose what you.
Exactly.
Alternatives to it, like what would be the alternative at enterprise level, the other tool, if you speak that.
Yeah, but there are not that perspective per se, but I mean there are tools that are being utilized for sure, right?
They might have,
That might, yeah.
they might themselves have the.
Zep is actually
Exactly.
is very popular product right
Yeah,
now
yeah,
for the
exactly.
memories.
Let's ask an LLM.
Yeah, you can just do Perplexity.
We can use this one, Perplexity or
Yeah. So Frank has another question. Thoughts on using Claude Code along with Zep memory to create long-term memory for large project delivery with a medium-sized development group. Any value there, or Claude.md files the best approach in your experience? So is it like, is it better to use Zep memory to create long-term memory for large project deliveries, right? When you have a medium-sized development group, or do you actually go with Claude.md files?
I don't recommend that Claude.md file because it's just very plain context.
Yeah, so it's basically Claude.md. What you need to do is you need to create your own Zep memory. I went through this personally, where I started creating Claude.md files over and over. To tell like where am I in the situation, and it actually doesn't keep track of what has happened earlier. So the first option, Frank, to your question, using Zep for the long-term memory is the best option.
Yeah, because one thing is that you can see the
You can
all
see
the
the
episodes.
you can see the context. You can see all the conversations that are going on, neatly written down, etc. Right? And so Padma has this case scenario. Gandhi built as an app, and instead of trying to fit this into an enterprise that's not ready, if this is placed as an independent product, then that's a sovereign sales route. Another perspective. So she's talking about what we talked. That nutrition app could be an app on its own.
Yeah. In
Yes,
fact,
we agree that.
we agree that actually I want to build a an app out of it actually.
Yeah. Okay, I think those are the questions that we had from the team from Zoom.
Okay.
Thank you so much for everybody to join this. We will actually share this in the channel pretty soon once I have the recording. And this 2.5 hours. Thanks for spending time on a Saturday.
Yeah.
Yeah, thanks.
Yeah.
Thanks everyone. Yeah. Thank you. Yeah. Thank you all. Thanks for joining today. I think yes, Kiran will post some of the videos also.
Yeah.
So yeah, you can watch the recording.
Thank you.
Yeah. Actually, can you hold on? Don't stop the share. Actually, I'm going to share the WhatsApp QR code so that people can.
Yeah. Okay. I will also share my GitHub repo.
Yeah.
Somewhere where we can get an email or something, or
You can actually. I'm sharing.
are you sharing it on the meetup?
Yeah, on the. Let me share this first, where the QR code comes through, so that you guys can join in.
But we are not on the Zoom.
No, you can actually use your.
So I'm putting my GitHub repo in the.
I'll share the screen. Hold on. First, finish up your GitHub repo. Yeah, take that from there. And what I'm going to do is I'm going to share my screen.
And also, I want to kind of a shameless replug of my YouTube channel. Please follow it.
Yes.
Yeah, but the YouTube channel is.
It's in request on LinkedIn already.
Yeah. Okay, and 1 second actually. Can you stop your share once?
Yeah.
Yeah, you can use that QR code to join the. I'll accept the request once you guys are done. That's where we have like 200 plus members. We'll be talking more about all this, what's happening.
Yes,
But big thanks for Kiran because he's the one who started this WhatsApp group. Without this, we would not be meeting in this room today. So big thanks for it.
Yeah. Thank you all for coming, and and we do have the plans to have there's one guy, Gautam, I don't know whether he's online. He's from Microsoft, and there's another one person from Google. They'll be talking about AI governance in the upcoming session. Yeah, and we'll have some more coming up.
Those will be in the weekend.
We'll see. I think it could be on a weekend or, I mean, we'll plan for it. Yeah. Weekends are more better for serious talks like this, because we need to have the focus also. That's what we're planning to do.
Yeah.
Right? And we have some podcasts coming up, so, I'll publish once we have it ready. So he's Bharadwaj. He's going to help me set up those podcasts and stuff like that. So if you guys have anybody who is interested to come and speak, let us know.
Okay, we can end this call, right, Kiran?
Yeah, I can.
Sure. Yeah.
Thank
Thank
you
you
all.
all.
We're ending the call now.
So we are ending this call. Yeah.
Thank you, Kiran. Thank you, Gandhi. Bye.
Thank you, everyone.
I can come and talk about my experience from us.